Hey everybody, it's JJ and we're back again for another ASUS PCDIY hardware live stream. Give me 1 second to go ahead and bring that audio down there. Fantastic. Hopefully everybody is enjoying their Friday, wrapping out things on a positive and productive footing. We've got a good number of things to jump into. Of course, it's been the launch for the 14th Gen series processors from Intel. Of course, refresh Z790 series based motherboards. That's actually what we're going to be focusing on. We actually had a full in-depth live stream that we did, of course, earlier this week, where you can go ahead and dive into that, and goes into all the kind of speeds and feeds, all the details regarding that. And we actually have an upcoming performance live stream, but this one's going to be maybe a little bit of a mix of the both. So we're going to recap essentially the introduction of our latest generation boards. Make sure to answer anybody's questions you guys might have. Maybe if you missed out on that live stream, feel free to go ahead and ask your questions here. So we'll go ahead and we'll touch on each one of the actual new series that we've gone ahead and introduced, or new models for the respective series. So we've got one brand new TUF gaming model. We've got 3 new ROG Strix models with the -A, the -F, and the -E, all version 2. And then of course we've got the new Maximus series, where we've got the Maximus Apex Encore, the Maximus Dark Hero, and then we have the reintroduction of the Formula with now the Z790 Formula board. So we'll touch on that. I've actually also got my demo system right here. It's just a little bit off there to the side, but I'll go ahead and be bringing in my demo system there a little bit later. We're actually going to talk a little bit about understanding kind of thermals and how they relate to overclocking, and if you utilize something like our ASUS AOC technology, which is now even on our most entry board with the TUF Gaming Z790 Pro. We're actually going to do kind of like a before and after. We're going to take a look at the results. We're going to take a look at some of the cool stuff that you can actually make adjustments for. I'll actually show you how you can do tempered or target based overclocking within ASUS AOC. We're going to take a look at AMP2, which is our latest generation of being able to take essentially non-XMP memory kits and being able to easily overclock them. So we're going to do a demo of that, and we'll see what else we have time for. So we've got a pretty packed stream. We'll cover also 3 new updates in terms of our peripherals, where we of course now have the release, or at least the initial limited release, of the ROG AZOTH keyboard. So that's our flagship gaming keyboard, which is now available in Moonlight White. The now limited availability for the ROG Moonstone, which is our glass gaming surface, and then also the ROG HARPE Ace AimLab Edition, where we now, just like the Curious Aimpoint and the Gladius 3 Aimpoint, we've gone ahead and refreshed, and we have both black and white models available. So we'll touch a little bit on that, as right now we do have a limited, essentially launch kind of promotion going on with our friends over at Micro Center. So if you're interested in the Moonlight edition of the peripherals, except for the HARPE Ace, you're going to want to actually check out Micro Center for an initial period, as they will be available exclusively there. All right, let's go ahead and take a look and see who we have got joining us here for the stream. We've got the one, the only Snef Computer Design, man, the Grandmaster from up north there in Canada, man. Fantastic to have you here on the stream. We've got Erica joining us on the stream, as always. Thank you so much, and letting us know that the audio sounds good. That is great. Hey, the one, the only Rhodes PC, man. Fantastic, man. Thanks to have you here on the stream. Very, very cool. We've got Pidgey PCs. We've got both Michaels joining us. So fantastic. Thank you for joining us. We've got Mike Russo joining us. We've got the one, the only Sumin. We've got Get WRXD also joining us as well. Tech, hi, how you doing? Thanks for joining us. All right, so let's get ready to go ahead and jump straight into it, guys. We've got a good number of things to jump into here. Let me go ahead and make sure that I've got my refreshing beverage, just in case I get a little bit parched. All right, guys, so let's go ahead and quickly jump into just giving a little bit of a slight introduction here. So I'm going to go ahead and jump straight into it. Just give you guys a quick recap of the Z790 chipset. What do you get, of course, if you do decide to adopt? So for those of you, of course, already on Z790, of course, this is still the same exact chipset. I do want to go ahead and clarify something that some people have a little bit confusion on. Technically, yes, Z690 supports socket 1700 series processors, so you can support 12th gen, 13th gen, and 14th gen. You just need to make sure to update the UEFI BIOS and the MAI firmware. Some people think, though, it's the same exact thing, and it's actually not. There was a change in terms of what was called the downstream PCI links. So under the Z790 chipset, when we actually take a look at it, let's actually go ahead and take a look at the block diagram. The block diagram will essentially explain to us how the PCI functionality is allocated across both the CPU and the chipset. And when Intel implemented essentially the Z790 chipset, there was essentially more allocation that was provided to what's called the downstream link. So the downstream is essentially going to be all those arrows that are coming out from the chipset. And this is your upstream DMI link, which is essentially still the same. The reason why that's important is that some people are kind of wondering how, the higher number of M.2 drives will figure out in terms of, does that take away from me being able to run things? How does that operate? There's a lot of complexity when you talk about how you share PCI lanes in different types of configurations, but for the vast majority of users, it's not really something you have to be kind of concerned with. If we kind of do a rough breakdown and we compare this to a motherboard, for one, if we take a look at the CPU is going to give you 20 lanes, which is going to be the same just like it was in the past. You have, of course, up to Gen 5 support, but of course there's no Gen 5 based graphics cards. So you can either run, of course, that GPU in by 8 or by 16. Not all GPUs are natively by 16, so keep in mind something like a 4060 Ti, for instance, is only a by 8. So there's actually leftover lanes that you could be used for other items. So here you can see, of course, up to 16, and then you have a dedicated reserved 4 lanes for your PCIe NVMe. So that's great because that means you have a dedicated essential level of bandwidth for your high-speed PCIe NVMe M.2 SSD. So it doesn't affect anything when it comes in relation to M.2 graphics cards or anything along those lines. Excuse me, M.2 based SSDs. So there's no essentially there's no configuration that you have to worry about. Essentially, those are always going to be independent of each other. Now, when you see other slots that are going to be on the motherboard, so generally slots like 2, 3, 4, or maybe even 5, as the minimum for this generation, all of the refresh boards are going to have at least 4 slots, and actually most of them are going to have 5 slots. Those will generally be linked into the chipset. Now, some of the higher end boards, it does get a little bit more complicated because you could potentially be pulling a slot with Gen 5 from the CPU. And your GPU and your CPU would be essentially allocated 8 lanes, and then you would be giving some of those lanes to that M.2 based SSD. But in reality, that is not a concern because even with, like, let's say a 4090, it is not going to be bandwidth constrained even running at by 8 operations. So I've seen some people ask questions about this. Hopefully that gives you a little bit more clarification to understand. For the rest, it's pretty straightforward. What are those key things that you're going to be coming into if you're coming maybe from an older platform from 2, 3, 4, 5 years ago? You're going to, of course, have DDR5 support. Z790 and the latest generation Intel CPUs do actually support both DDR4 and DDR5, but all the new motherboards that we're going to talk about are only DDR5. If you want DDR4, look for our motherboards that say D4 in terms of the end of the model name, okay? You're going to get a minimum of USB 3.2, with actually every board at least having USB 3.2 Gen 2 by 2, meaning up to 20 gigabits. So every single board, even the TUF gaming board, will give you 20 gigabits connectivity. Every board is going to give you 2.5 gigabit networking. Every board will give you Bluetooth and Wi-Fi with a minimum of at least Wi-Fi 6E, and actually most of the motherboards will all be Wi-Fi 7. And then, of course, your standard technology as far as, SATA-based connectivity, PCIe expansion, things along those lines. So that's pretty much what you get when you're talking about coming into the Z790 chipset. Now, before we get into the boards, I'm going to go ahead and quickly just talk about what would you get from a minimum perspective on all of the motherboards within the respective lineup, okay? So as I noted, we've actually got multiple series. So let me go ahead and just show you here. If we take a look at the 3 series that we are going to be offering, these are the 3 series that we're going to be talking about. So we've got our TUF Gaming, which is just going to be one model, the TUF Gaming Z790 Pro. We then will have, in addition to that guy, we're going to have the ROG Strix series. So that's going to be the ROG Strix, which we're going to have 3 models here, the -A, the -F, and the -E, okay? And then last but not least, of course, for many of you, the favorite series, which is going to be the Maximus series, where we're going to have, of course, the Dark Hero, the Apex Encore, and the Formula, okay? So those are all the boards, and like I said, we'll quickly touch on them. If you want way more information, again, we have the full launch live stream that we did earlier in the week. There'll actually be a consolidated edited version, which I'll be posting later today, with actually some supplemental kind of pieces of information. We'll also have dedicated overviews with performance testing that'll be coming out over the next kind of week or 2 that we'll have on the channel. And like I said, next week, we'll also have a focused live stream where we'll do actually specific kind of overclocking on 14 gen, providing DDR5 insights and stuff like that. But today we're also going to be doing some demos. So we've got a lot kind of packed in to kind of for this stream and for, of course, the upcoming week as well, okay? let me go ahead and see if we got any quick questions that might have come up right there. Hey, Connor, man, happy to have you here. Thanks so much for joining us. The Tech Alan, man, fantastic for joining as well. Jenny, man, thanks for joining us here as well. All right, Sniff already showing some love. I like that, right? For the Formula and for the Apex, right? Yeah, they all look really, really good, but definitely, I do like those kind of distinct lines that I think that the Apex has to offer. Okay, so let me go. Where do we want to start first? Like I said, okay, what's the minimum of, I think, what we're going to be getting when we talk about the boards, right? So let's break this down quickly right here. All right, so first and foremost, so what do you get on all of the boards, right? So the easiest way to think about this is I just showed you essentially that TUF Gaming, the ROG Strix, and the ROG Maximus. So it doesn't matter of any of those 7 motherboards that you pick, what would you consistently get? Well, all the boards can readily run any CPU stock or overclocked. Flat out, doesn't matter whether you have a 12900K, 13900K, a 14900K, whether you run it with stock, whether you run it with MCE, whether you run it with the temperature target, whether you decide to aggressively overclock it with a high-end AIO cooler, or whether you go with a custom water loop. They're all going to give you great performance. None of them with thermal throttle. They'll all give you great, very good stability and reliability. Are there going to be margins of improvement as you move up in the boards? Yes, there will be also more advanced features, but you don't have to purchase a board thinking that I have to go to a higher end board to be able to get a stable and reliable experience, even if I do want to pursue overclocking. And especially I think with the ASUS AOC being implemented on the TUF Gaming motherboard, that's even better, right? Because those people that might have a more moderate budget and looking for a great choice, it's going to be solid. Robust DDR5 experience. Now, all the boards you're going to see on the QVL even have higher than this. I've actually gone for a more conservative marker because the reality is that your CPU IMC, so the integrated memory controller, does have a determining factor on how much you can overclock your memory, regardless of what we design our motherboards for, regardless of what we validate for, regardless of what the memory is that you purchase. Your memory controller is a limiting factor. That being noted, Raptor Lake and now of course with 14th gen offer very strong IMCs, so it is generally pretty much possible for, I'd say, the majority of CPUs, so that's going to be generally upwards of 70%, 75% of CPUs will comfortably be able to hit 7000, 7200 MT. That's going to be in a single rank configuration, so 2 DIMMs. That's usually going to be 32 gigabytes or 48 gigabytes, and all those boards can do that without a problem. Again, even if we take a look here at something like, let me go ahead and let me see right here, like our TUF Gaming board. Let me see right here. I think I should have it. Here's a great example. This is just, like a realized real world test right here. Here you can see the TUF Gaming board doing 7200 full stability, 1 hour OCCT memory stress testing, no issues. And I think that that's probably even higher end than what most people would buy for something like a TUF Gaming board, right? They would probably maybe buying closer to maybe something like a 6600 series kit, or maybe even 7000. 7000 has gotten pretty price aggressive, so it's not super expensive. It's pretty reasonable. But this again shows you that it's entirely possible. Okay, so again, very, very good performance. And for those of you that really want to push the memory, even without going to an Apex, you can easily be looking at 74, 7600 on other motherboards within the lineup. Okay, and we'll talk a little bit more about DRAM overclocking as we kind of get into it. Okay, but let's go back here. What are those consistent items you're getting? ASUS AOC. That's going to be a great feature that again now is on every single motherboard. Even the TUF Gaming model has ASUS AOC on it. They all have the AMP2 memory technology. We're going to specifically go a little bit deeper in this stream, and actually I'm going to demo for you AMP2 and AIOC, specifically show you what we have there. They're all going to have a minimum of at least 4 M.2 SSD slots, and they're all going to have the Q-Latch design, which is that easy kind of M.2 SSD installation design. And even the minimum of 4 is really only for the TUF Gaming motherboard, because once we pretty much go up from that, they all have 5 slots that will be available on the motherboards. Every single board has Wi-Fi and Bluetooth with a minimum of Wi-Fi 6E. Most of them are actually all Wi-Fi 7. Everything has 2.5 gigabit networking or better. They all have Fan Expert 4, and they now all have AI Cooling 2. AI Cooling 2 is our kind of more advanced automated fan tuning and calibration. And maybe I'll even demo that one for you guys today too. They all have, 20 gigabits USB-C and a minimum of 8 rear USB ports. So 20 gigabits USB-C is nice to see as far as if you just want faster speeds, right? The VRM Assist fan, that's actually a tie-in. Don't worry about that. That's not actually accurate. So that's for something else. It's a misnomer on my side. And then what else is going to be consistent? They all, of course, have PCI Gen 5 slots, not for M.2 SSDs. That's for your primary, of course, graphics card slot. But they all have the Q release design, which is that really cool design where you can just press the button to eject the graphics card. I'll show that. They all have QLED with dim detect. So that's not just the 4 LEDs. We now actually have a new diagnostic system that actually helps to intelligently detect the memory if you have it physically installed. I'll show you guys a demo of that. It's pretty cool. They all have at least 3 RGB headers. They all have Thunderbolt headers, or they have Thunderbolt. Thunderbolt is pretty much going to be for the Maximus boards, but then pretty much everything else has a Thunderbolt header. So if you want to be able to add Thunderbolt, you can do that. They all have ProCool power connectors, which are thicker pins for the CPU power input. That just gives you better current handling. It reduces temperatures within the actual pin-to-pin contacts. It's just a better way to be able to design the connector. Safe DIMM design, which actually improves the overall stability and reliability of the DRAM slots. They all have a safe slot, which is just a reinforced slot for the graphics card. They all have an integrated I/O shield. And then, of course, they all have our ASUS UEFI BIOS, which I'm biased, but I think we have the best BIOS in the industry. So that is kind of everything you're going to get. Now we're going to go specific into each one of the boards quickly here. We'll touch on kind of what are you going to be getting as you go into the respective models. We're going to be doing some demos in a little while. So again, if you guys are interested in seeing actually how AIOC works, if you want to see how AMP2 works, if you want to see the dim detect feature, if you want to know more about DimFlex, which is a really, really cool, exciting, innovative technology for DDR5 overclocking, which is on the ROG Strix models, which for those of you who really like to push DDR5 frequencies, it's an absolute breakthrough at being able to stabilize and ensure the best performance possible. So DimFlex is going to be pretty cool. So we're going to have it packed in. We're going to be talking about that. Let me go ahead and see if we got any quick questions that might have popped up within the stream. So Neymar is asking, which Wi-Fi 7 cards are being used on these new boards? Yeah, so that's actually a very good question. Some competitors are actually using solutions from other vendors. We've decided to go with Intel. So Intel is who we are utilizing on our motherboards. We feel that it's actually the best performing chipsets in its class. It's also, you want to keep in mind that ASUS is really a worldwide leader and a market leader with Wi-Fi 7 offerings when it comes to routing solutions, right? Other companies don't necessarily have a full comprehensive networking division that we've had, where we've had a networking division for over 15 years, producing, flagship series products. So we have very, very good understanding of working with the chipset vendors on the router side, right? Optimizing those designs, pairing those with our routers, doing that interoperability testing, and really getting a great experience. So what you're going to see on our products will be Intel Wi-Fi 7 based wireless chipsets. Okay, some other companies may be using other wireless based chipsets on their products. Okay. JY goes, just bought an ROG Strix Z790-A. I don't know if you bought the -A2 or you bought the original -A. Can it run 8000 MT? I would probably say, one, your IMC quality is probably unlikely that you have a good enough IMC to run 8000 MT. So unless for a fact you've been that CPU and you know that it has that, or it's coming as a known commodity that does that, don't expect that your CPU can hit 8000 MT. I can tell you, me personally, I've tested, 20 CPUs, and there's definitely only a handful of CPUs that have an IMC that can actually stably run at 8000 MT. So that's one. The board, that -A is a 6-layer PCB board as opposed to some of the higher end boards which have an 8-layer and a low loss PCB, which would be advantageous, especially as you start to get into higher frequencies. I would generally recommend that if your target is like 8000 MT, that you really be looking at probably the -E and the Maximus series is higher. I have personally been able to hit 7800 MT on the Strix series, again with a strong enough IMC and also with the thermals in check. Thermals are an important part, especially as you get to higher frequency for DDR5 memory. But I would say nominally the target you should probably be looking for on a board like that, like the -A, is probably closer to, I'd say, that 72 to upwards to maybe about that 7800 range, right? Where probably even 76 is I think a higher likelihood of success. We have validated up to 7800, and it's a possibility you could hit 8000. But if you really are looking to buy, like I've got this actually kit right here on this TUF gaming board that I've set up, that's an actually 8000 kit of memory. If you really want to make that investment, again, my recommendation would be a minimum of the -E, if not moving over to, like I said, the Apex or the Dark Hero as my recommendations, or the Formula, either one. Okay. All right. Chris is going 7200 MT XMP stable on the Apex. Yeah, that's pretty good. Again, you still have to account for like the margins of the IMC, the memory controller quality. But as I noted right there, right, if we go back again to my result right here, this is 7200 MT XMP out of the box on the TUF gaming motherboard. Okay, so the Apex, which is a much higher end board, has a much more advanced DRAM topology, has more advanced PCB layer. It's a low loss PCB design. It has even better memory power topology. Everything's upgraded. You can already see if you wanted 7200, I can do 7200 on the TUF gaming motherboard, right? Will you even have a better success rate for 7200 across the variations of dies and densities? Yes. So still unquestionably, if you want a better OC experience for DDR5 memory, the Apex will unquestionably give it to you, but that's entirely possible. Do keep in mind though that there's still, like I said, you know, the majority of 13th and 14th gen CPUs, the IMC is going to be upwards of being able to support in most situations. You know, 75% of CPUs are going to be no problem 7000, 7200, but you will have marginal CPUs in their IMCs, so there will be ones that will actually have more difficulty stabilizing that, and that's not a fault of the board, that's just the IMC, it's just the silicon lottery, right? Silicon variance that is inherent to overclocking, right? That is a reality. All right. I'm going to get into the boards here, but we got great questions, and that's what these questions are all about. Where does the Z790 ProArt sit in? That's a great question. The ProArt is not going away, just like here, the Prime is not going away, so we will continue to offer both of those models in terms of our Z790 series. They weren't updated or, let's say, quote-unquote refreshed, though, but the spec is still outstanding on boards. Still pretty much almost everything we talked about, you still get on those boards. The Z790 Prime doesn't have ASUS AIC, but almost everything else that we talked about is generally there. The ProArt motherboard is still a great choice because you get Thunderbolt on there, you get 4 M.2 slots, you get 10 gigabit networking. Probably the only thing you might miss in compared to maybe some of the refresh models might be something like PCI Express Gen 5 SSD support, but it's a very good choice. And again, in terms of overclocking capability, DRAM stability, all those things, no issues in that regard. Still a very, very good option. Okay. All right. Let me go ahead and see right here. Tech notes, 7600 stable on the Strix-E. Yep, that's exactly what I was saying. No problems there. I would expect that. And that's actually what I already showed off in like our prior PCDIY community results, right? Where I showed off 7600 on multiple of our motherboards in the ROG Strix and the Maximus series from the prior generation. Again, even from Z690 to Z790, there was an inherent refinement of the DRAM topology and the signal routing, which was optimized. So gen to gen, while Z690 will do pretty good, and you can generally even hit, you know, 7000 MT, maybe even a little bit better than that. Of course, there are exceptions like the Apex that it can even go higher than that. Generally, that's around where the target is, where Z790 saw a comfortable, nice little bump up and further improvements because of those optimizations that we did to the PCB design, the DRAM topology, the signal routing. So gen on gen, like Z690 Hero versus Z790 Hero, even before we get to now the Z790 Dark Hero, already saw a DRAM scaling improvement, taking even the same series CPU right now. Okay. I have the ROG Maximus Z690 Extreme. What Z790 board would be the closest to that? Technically, actually, the closest would have been the Z790 Extreme, which is the refresh of that model. We did that model has now essentially all models except for pretty much the Hero board are always a limited production. So the Apex is limited, the Formula is limited, the Extreme is limited, and generally when we run through kind of our channel production, they're no longer available. It doesn't mean we don't support them because of course you have a 3-year warranty, UEFIs will come out for years, things like that. But right now, the closest in terms of the refresh models would probably be the Formula or the Hero. Those would be the two that would be kind of the most equivalent, although technically the Extreme is even higher. It's a little bit different because it's an EATX board and offers some stuff, but there's some interesting analogous, and I can give some more contrast, like if you wanted to maybe understand what would be the value if you wanted to upgrade, but Z690 Extreme is a very, very nice board still right now, so I don't really see why you would want to upgrade unless there's some specific, I don't know, feature, maybe like Wi-Fi 7 or something that you would really want coming on one of these newer boards, okay? DBLOT is going, well, support 4 sticks of 7200. Doesn't have to really do with the motherboard. It does to some degree in terms that, you know, technically the DRAM topology on boards are optimized right now for daisy chain, which is generally for 2 DIMMs. So 1 slot per channel, 1 DIMM per channel. But 4 DIMM, there's very few 4 DIMM kits on the market. And right now, to your point, there's not one memory manufacturer that makes a 4 DIMM 7000 empty kit. It doesn't even exist. So you taking 7200 means that you're going to be buying 2 kits and forcing them together, which they were never designed to do in the first place. And if you correctly understand the Intel Pore Table, that is the DRAM operating specifications. When you add actually slots per channel, DIMMs per channel, and density, you actually will reduce your DRAM scaling. So the scaling will never be as high as it will be for single rank. If you want to be targeting speeds upwards of, you know, 6800, 7000, 7200, you need to be focusing on single rank configurations. So that's going to be 2 DIMMs, whether that's going to be 32 gigabytes or 48 gigabytes. You know, maybe 2 DIMMs with a dual rank is possible. So you're talking about 64 gig that you could maybe start to get close to 7000, but that's going to be even a stretch. Dual rank and it's any 4 DIMM configurations is just far more stressful to the memory controller and to the way that the boards are designed that it's not congruent with that. So no, I would tell you that's not going to be possible. It's not realistic. There are edge cases. We've had configurations. I've even done a personal test on a Z790 system on our Extreme board where I have been able to find a CPU, good enough IMC, find the right tuning configurations that I could actually do a 4 DIMM 7000. That's rarefied category. For the vast majority of people, it's not a realistic target. So I would tell you no. Your target, if you want to run 4 DIMMs for whatever reason, I don't know if it's a density reason or it's an aesthetic reason that you want to run that, but if that's what you want to run, you need to bring down your expectation for the memory. Okay. All right. Okay. Let's go ahead and we answered a good number of questions there. So let's keep it going. All right. So let's quickly just touch on here. The first one, we'll jump into the stack here. We're going to go with the TUF gaming board. So let me go ahead and bring this one in here. So this is going to be the first one here, which is going to be the TUF gaming. And this will be the TUF Gaming Z790 Pro. And all of the motherboards are now available. So you can go ahead and pick them up right now. We've already had people in our PCDIY group be able to pick up some of these amazing boards. So yeah, you can see them on the ASUS store, Newegg, Amazon, Micro Center, B&H, Autorama, any one of the channel partners. And if they're not up yet there across every single partner, you know, probably within the next, 5 to 10 days, you'll pretty much see them rounding out their overall availability across the board. Okay. So let me go ahead and bring up the first board here. I do have the TUF Gaming. Normally I would have just taken it out and shown it to you, but since I have it set up for my test bed, it's a little bit harder to show. So I'm going to go ahead and first show you some nice little B-roll right here of it. We'll take a look at some images. We'll talk about kind of what are the new things on there really quick, and we will go from there. So give me 1 second here. And go ahead and where do I have it here? TUF Gaming. Yep, here we go. Our TUF Gaming board. And I think, yes, we'll go with that. So there we go. Perfect. All right. So let's go ahead and take a look at that. Let me lower the volume right there. So the ID design is going to be pretty similar to the prior generation. It's going to be a little bit tweaked. I'll show you some of the differences. Of course, like I said, we'll also specifically highlight what you're going to be seeing in terms of what's going to be new for this generation. That's one of the newer parts right there is going to be that inclusion of that 20 gigabit internal connector. It also has 30 watts of power. You see that really cool, easy, quick connect design for the actual Wi-Fi antenna. But now let's go ahead and actually take a closer look here straight at the board. So go ahead and bring it up right here. And then we'll take a look here at the kind of what's new specific for this version compared to the prior version. All right. So here we go. You guys can see, oh, sorry about that. 1 second there. Let me make an adjustment there. There we go. Okay. So here you guys can see the board. Overall, very nice, clean ID designs, pretty much all monochrome. You only have one lighting zone that's right here. Pretty much everything else is going to be black, gray, or white. I think it looks really, really nice. It's going to really complement pretty much any build. There's no colors to contend to compete with the board. Robust teamed power stage delivery. You got your dual ProCool power connectors, 3 RGB headers, 20 gigabits internally here with 30 watt USB-C support, your legacy front USB 3, the quick eject mechanism right here for the PCI Express, one M.2, 2 M.2, 3 M.2, 4 M.2. So 4 M.2 SSD slots with 3 of those having heat sinks on here as well. And you've got tons of fan headers and an AIO pump header on here as well, the ASUS AOC, and then of course your TUF Gaming audio design. Now, one of the things is that's actually cool right here, and let me go ahead and just shut off my demo system. I probably shouldn't do this because this system is actually on. Actually, give me a second so I can shut it down the right way. I'll just do that. 1 second, guys. I'm going to switch my input here. All right, guys, so give me 1 second. Let me shut this system down here. Okay, so when that shuts down, I'll actually show it to you, but the slot layout is actually pretty intelligently designed compared to some actually competitors. I think actually this is a better slot layout than what you're going to see on a lot of other boards in the same price range. So I'll talk about that in a little bit once I actually bring that board out here. So give me a second here. You're also going to see here in terms of the rear I/O, what are you going to have? Well, 10 gigabits. 5 gigabits, 5 gigabits, 10 gigabits, 20 gigabits, Wi-Fi 6E with Bluetooth, and then multi-channel audio and 2.5 gigabit networking. So that's going to be 2, 4, 6, and then 8 ports with 2 USB-C. So quite solid in terms of the overall core specification set there. And let's quickly take a look at actually going to be what's new. So let me bring up my what's new chart here for the TUF Gaming board. And this is going to show you essentially the compare and contrast. So if we compare right here, this is the old TUF Gaming. Well, it's actually still available right now. There's a $50 difference between these. So the TUF Gaming Z790 Plus, and here's the TUF Gaming Z790 Pro Wi-Fi. You're going to get an aesthetic update, which of course is just, you know, an aesthetic item. Higher DDR5 OC support, an internal 20 gigabits USB-C. This was a maximum of 10 gigabits. You're going to get ASUS AOC, AI cooling, AMP2, although AMP2 will be rolled out via UEFI to other Z790 based motherboards. Q antenna. So they're both Wi-Fi 6E, but this will have the new Q antenna design, QLED with dim detect, and then the PCI slot layout, which you can actually see is a bit different between these two boards. Okay, so let's go ahead and take a closer look now actually at the board, how this slot layout works. And if you guys have some questions, feel free to go ahead and ask right there. Let me go ahead and get my camera connected right here, and we'll show you some of this stuff here. So give me 1 second. DePoets, man, happy to have you here. Oh, DePoets is saying, overclock all the things. Yes, and we're going to actually show this ASUS AFC demo in a little bit. I got some really, really cool ways to compare it to. I'm going to show you like at a full stock default parameter, what's the performance uplift, how you can do temperature target based overclocking. So if you wanted to say hit a ceiling of only 80 degrees and have the maximum of the overclock be defined by that ADC target, how you can do that. We're going to show you the AMP function, which is really, really cool. So we've got some other stuff that's going to be really, really nice to check out in terms of just understanding the value add that these features are bringing when it comes to easy performance tuning, right? Yeah, so that's pretty expectations. PGPCs is saying, yeah, on the Z690 formula with the 13700K, the most recent BIOS, I can get 6,000 with all 4 DIMMs stable. Yes, that would be my expectation for Z690, Z790. Z790 will get a little bit more. I think it's possible to stabilize 4 DIMM configurations with 6200 plus, so that could be up to around maybe even 6600. But then again, the quality of the IMC, even some board variants and the memory topology is going to be more valuable. 8-layer boards and plus will be the best. So the formula, of course, being a higher layer count and also being a low loss PCB design will be advantageous for those that are going to be pursuing that. But really, my kind of overall recommendation for people that are bent on having to go with a 4 DIMM configuration is 6000 MT should really be your realistic target. Because keep in mind that the actual port table, if you go with a 4 DIMM configuration, it's even worse if you go with a dual rank 4 DIMM configuration, it goes down from the default official memory speed. So as an example, like in Alder Lake, with 12th gen, your base frequency is 4800, but if you went to a 4 DIMM dual rank configuration, your speed literally dropped all the way to 3600 MT. That was the official rated speed for actually 4 DIMMs in dual rank. Some people thought, oh, it's the same speed whether I'm running 2 DIMMs, whether I'm running single rank, whether I'm running dual rank. No, it's not. It will influence the memory controller at actually even what it's officially designed. So you can think about going from 3600 to something like 6000. That's a huge bump in terms of what you're asking the memory controller. It's quite impressive that DDR5 already is showing such large levels of scaling, but this is what you have to kind of keep in mind, okay? All right, let me go ahead and grab the board right here. Let me actually disconnect my power here really quickly. All right. Oh, my cooler attached there. All right. All right, so of course one of the cool things right here you'll be able to see, and probably this is part and parcel for most of you guys have already seen this really cool feature. If I bring my little test bed here, one of the cool things that we'll see with this test bed is actually it's coming up right here. This is the brand new TUF Gaming LC2 360 that we're going to be using for the ASUS ASE demo. But most of you are probably already aware that one of the cool features that we introduced previously on our boards was, of course, the PCI Express ejection mechanism. So there's a little button on the motherboard. I'll show it to you, but I just press that button and it allows me to easily take out this graphics card, right? So it's a very, very, very simple process. So let me go ahead and move this keyboard over here, and we're going to throw this board under the camera. We're going to take a closer look at that slot layout and show you, I think, where kind of some advantages are going to lie. Don't want to pull that power supply there. All right. Let's go ahead and see here. Okay, here we go. And let me go ahead and brighten this up for you guys. Okay. So let's go to our camera right here. All right, so here you guys can see the actual board nice and close. You can actually see that TUF Gaming LC cooler. I think that TUF Gaming LC cooler looks really, really good with this board. Just that really kind of cool logo right there. I'll see if I can light up a little bit for you guys there. There's not really much lighting on this motherboard though. It's just really that little corner right there. So there's not too much of a difference between this board running kind of with no lighting and with lighting, right? But if we go down here, this is really where I want to kind of focus on. So let's look at that right there. I'll actually disconnect the board power because there's not really any need for the board lighting. But the slot layout. Some competitors, what you're going to find is, so first, we always will pretty much on all the boards have an M.2 isolated above the by 16 slot. That makes sure the one you can always access it. It's always going to be thermally isolated. So that's going to be nice. If we do take our GPU, take for instance right here, I will grab something like right here. Give me one sec. This is our dual 4070. This is 4070 Ti or 4070. It doesn't matter. They both look the same. But you can see right there, right? Install the card. And the cool thing is, compared to some competitors, that slot is going to be immediately accessible right there below it. And then your two other M.2 SSD slots are also going to be available. I can tell you, take for instance on a competitor, right? They actually have their design, which is a bit different. You're going to see a big M.2 heatsink that's going to cover like 3 slots or even 4 slots. And so with that design, the moment you put the graphics card over it, you now have lost access to all those slots. It means you have to remove the graphics card to be able to get to these other slots. There's also a little bit of a thermal choke point because the GPU will produce a little bit more ambient heat pooling in this section. So even though you have that heatsink, you're adding more immediate heat to those drives. So I think having a little bit more thermal isolation is advantageous in the way that we've gone ahead and designed our layout. So it's subtle. You might not realize that there's a difference there, but it does make sense, again, in terms that if you look at the layout design here, you can see how that works out. And even if I go into a bigger graphics card, let's say you want to go to like a min-max configuration. So I'm going to go ahead and go really big. Here's a 4090. So this is a huge graphics card, but you could min-max your configuration. And you can see even when I put the 4090 right there, that whole bottom slot is still accessible, right? So I still have one M.2 SSD slot and another M.2 SSD slot that's available. So I can remove those heat sinks and I could be good to go. Now, of course, it's very easy for me to go ahead and be able to remove the graphics card because you have that really cool Q release design. You can see right there, there's that little latch. I can, well, not a latch, but the button. I can press the button and I can just pull out the graphics card. So it's a very, very easy way to be able to get to the graphics card. But that's what I'm talking about when it comes to kind of the layout design, where I think that the layout design provides some sensibility. Hey, Thomas says, thanks for all your info. Your last video sold me on the Dark Hero. I'm waiting for it in the mail now. Man, fantastic. Thanks for being Team ROG. Man, Team Maximus. Yeah, the Dark Hero, it's an amazing motherboard. Really, you know, I think you're going to be absolutely really happy. I mean, it's got about pretty much every feature you could have on it, and it's built for performance. So it's going to be a great experience. So that's going to be one thing. Let me go ahead and show you guys the dim detect feature. For those of you that didn't check out our original stream, Again, I want to recap everything, but I wanted to show you that slot layout thing right there. So most of you are already pretty much also aware on the Q latch design for the M.2 SSDs, right? There's no screw, so it's just a really easy way to install that. Quick little demo right there, right? A little subtle thing you guys might not know, but this is one of the changes right here that we did for this generation. Now this whole thing is one big heatsink. So this is a heatsink, and then it extends in underneath this portion of the shroud. But a cool little details right here, this little labeling, we actually have multiple textures. So this is matte, this has actually an embossed texture, which is actually shiny, and then this is actually a textured rubber. So it's kind of cool. It just gives a little bit of a difference. It's just a nice little kind of again, it's an aesthetic detail, but I find it interesting. Okay, so let me go ahead and show you guys the dim detect feature. So normally right over here, you guys can see the QLED, right? So those would be your 4 LEDs, right? So let me go ahead and get my power supply. So give me 1 second. I'm going to get my power supply, guys. Okay, had to just get my PSU right here. So the cool thing that you're going to have is that traditionally, right, everybody's aware that those little lights will be one for the CPU, one for the DRAM, one for the graphics card, and one for the boot device, right? Well, the cool thing that we did is we actually have a little bit of logic on here. There's actually an auxiliary sensor, and the sensor will now help us to actually track information resident to when the DIMM module is actually installed. So let me go ahead and get my power cable over here from my PSU. Okay, let me turn on the power there. Okay, so you guys can see now we got the little lighting there because of course it's sensing the 24-pin motherboard power. So I'm going to go ahead and open that up. And there you can actually see. So right now, you guys notice right there, let me see right there. Can you see it? Let me see right there. You'll see right there that the actual light is turned on the board. So that's actually letting you know that one, there's actually no memory that's actually installed, right? So let's go ahead and put a DIMM in there. But let's say I just seeded the module, right? And so maybe I'm a first-time builder and I kind of don't do too much. That actual light is still lit up. So that LED, you can actually still see it's still on, right? So now we're going to go ahead and depress it because we're going to fully make sure that that module's seated. And you'll see that the LED turned off. You see how the LED is no longer on? So that's what we actually mean by dim detect. So this is not going to be necessarily, I don't know, for like PGPCs, Rhodes PC, you know, some of the great builders in here that really know a lot, DePoets, right? You guys have built tons of systems. You probably are pretty knowledgeable about making sure that you want to make sure to have those DIMMs depressed. You hear that click, you're going to go back and double check and make sure that everything's seated. But for some builders out there, that just gives you a little bit more clarity, a little bit more confidence in knowing that you've actually gone through that process correctly, right? So again, you can just see that the LED light is off now, but if it was on, it was essentially persistent. You might be, hey, I need to maybe go double check and make sure that my DIMM is physically installed. So that's, again, that dim detect feature, and that's on all the boards. So again, if you see that I open that up there, and if I tilt it up, you'll see that that LED is now gone on, because even though I have it fully depressed on one side, it's not depressed on both sides. So again, I'm going to go ahead and lock it into place, and you'll see now that that dim LED is now disabled, right? So overall, pretty easy, pretty straightforward, a cool little feature that we've got here with the dim detect technology, okay? So that's going to be a cool feature that we've got on all the boards. All of them are going to have that dim detect feature, okay? So that shows you guys that there, okay? All right, so we'll just finish recapping there on the TUF gaming board, and then we're going to go to the next board, because like I said, we don't need to worry about kind of touching on every little thing there. All right. So give me 1 second right there. Sorry if that created a little bit of a muffle there. All right, guys. So that is going to be the TUF gaming board. And again, just to recap right there, those are the new items right there. Higher DDR5 OC memory clock, DDR5 overclocking, like I showed you. 7200 was already what I showed you as a quick validation. 20 gigabits USB-C, AIOC, AI cooling 2, AMP2. In a little bit, guys, we're going to actually show you the way that ASUS AIOC works in AMP2, Q antenna, QLED, and the PCI slot layout. Now, one thing that I do want to lastly show you here, though, before we switch over the board, is going to be the Q antenna design. So if we do look at our antenna, most of you are probably familiar with, let's go to an older motherboard. Okay. So let me go ahead and go here to this older board. So this is going to be an older, this is a Z790 board. Focus in on there. Give me a second right there. Okay, so here you can see your SMA antennas. So this is what most of us traditionally know, right? And here's your antenna that you would normally get in the box. And many of you, can you tell me in the chat, have you ever had this pain point where you take this, and it's not super complicated, it's not like it's hard, but the SMA antennas, you do have to thread them. It's a threaded connection. So usually it'll take about, 3 to about 6 turns, depending on how much you torque in. But a lot of times what happens is what happens right there. You can see I screw it in and you kind of get that little knot, right? Or it kind of strands in, or it's not exactly how you want it to be, and you got to go back and maybe re-straighten the cables out, or you got to do anything like that. Yeah, I can turn the volume up a bump. There you go. Let me know if that volume's okay for you, but I think everybody else says volume's okay. So you might want to maybe turn volume on your side, but I didn't bump it up here. So you can see there's the Q antenna, right? So what did we do? Well, we revised it. We now actually made the antenna connectors a push fit connector. So this is a new design. So instead of you having to have a threaded connector that you're going to screw in, you'll just push it in. So let me go ahead and show you what that looks like. Go and grab another board here. So if you see right here are these connectors right there. Okay, those are the connectors, and let me get the antenna. And that's it. It's a really simple connection. So it's just a push fit connection. It does have actually some tension there, so it's not super easy to pull out, right? But it's very, very easy. You can just push it in, lock it into place, and then that's it. So very, very easy in terms of now being able to connect that. So you can see right there, you just push it in, you hear a little bit of that click, and you're going to be good to go, right? So really a simple process. There is also a benefit. We actually had to redesign the housing. So the housing and the connector itself is something that we further optimize. So one of the cool things that we did find when we went ahead and implemented this is that we were able to improve overall signaling performance. So we actually found that it actually provides better connectivity and better signal connection. Because sometimes when people are doing the screw in from the SMA, maybe they don't do it enough, or maybe they have a little bit of an issue that can cause an issue with the signal quality from the connection itself. So this design not only is easier, but it's more performant. And we actually pair that together now with actually an entirely new software suite that we have within Windows for actually the what's called Q antenna design. So that actually allows you to have a really cool thing where you have a visual map. So it tells you actually turn the antenna maybe 25 degrees, turn the antenna 25 degrees for actually better wireless signal. It also gives you a what's called a signal dB readout. So your signal analysis is presented to you. Even if you don't understand these things, it's just a visual thing that tells, hey, maybe make this adjustment so you can have a better Wi-Fi signal so you can ultimately get better performance. So that's a really nice issue. It's very, very easy to help you to make sure that you get the best performance. All right. There are any plans to sell aftermarket Q antenna and combo cards? Maybe. I mean, we do make wireless adapter cards, so we do sell, Wi-Fi 6, Wi-Fi 6E wireless adapter cards. So it could be that in the future, since we actually have this design, we might maybe bring that into our aftermarket offerings, right? So if somebody wants to buy our Wi-Fi PCIe card, maybe that is another value add, right? That you will be able to get that easy push fit antenna design. So I can't say that specifically right now, but that might be something that will be offered, okay? Will that software suite also work for the non-Q boards? That's a good question. I'll actually have to confirm with our team if we'll be able to backport that software, because again, it's a different chipset. There's different signal analysis and attenuation information, all that stuff that is specific to the design. But that logic of being able to maybe give you some directional access information and some of that stuff could potentially, of course, be reverted back to the older boards. But as of right now, that software suite is specifically to the new boards, not to the older motherboards, only to the new boards. Okay. All right, so that is going to be everything I think on the TUF gaming board. So we'll keep moving it along for there. Let's go into the ROG Strix board, and then we're going to get ready to probably maybe do a little bit of demos, and then we'll finish there on the Maximus series. So ROG Strix. Let me go ahead and let me make sure right here. Bring up my image here. What are we going to have for the ROG Strix boards? We're going to have 3 motherboards within the ROG Strix series that will be available. So you can see right there, we will have the ROG Strix-A, which is of course the board in white. We'll have the ROG Strix board-F, and we'll have the ROG Strix-E. So 3 models. We'll quickly touch on essentially the differentials there. I'm going to also show you guys all the pricing. So if for some reason somebody has any pricing questions, you'll know that. But all of the boards are available, so you can pretty much pull up the pricing right now. So it shouldn't be too much of an issue in terms of kind of figuring out the pricing. But let me quickly go ahead and make sure that I have my pricing slotted in here for the board so I can share those with you. So give me 1 second, guys. Gaming Wi-Fi 2, the -F, and the -E. Okay, so the ROG Strix-A is going to be $399. The ROG Strix-F will be $429. And the ROG Strix-E will be $499. And I'm going to clarify you for the difference, because sometimes people are very confused, like what's really the difference between, like, why do I get a higher model, especially when you look at the -F. The -F is a really, really strong value. The -A is also really strong as well, but more people buy black motherboards. Even though white is very popular, black is still actually significantly more in terms of the sell-through, but we have a beautiful comprehensive white product portfolio. It's the most comprehensive in the industry, but you get a lot more questions regarding something like how's the -F compared to the -E. So I'll definitely make sure to kind of break that apart. So let's go here first to the -A, kind of what's new there. So here you can see aesthetic update. We move up to 5 M.2 slots on the motherboard. Okay, now all of these slots will be PCI Express Gen 4. None are going to be PCI Express Gen 5, so keep that in mind. All PCI Express Gen 4. Unlike the TUF gaming board, though, all of them now have M.2 heatsinks. So the other board, remember, had 4 slots, right? And 3 had heatsinks. This one, all 4 have slots, okay? You get the new DimmFlex technology. So DimmFlex is very, very interesting. It's a little bit complicated, but I'm going to try to kind of break it down for you a little bit kind of easier. So if we go into our UEFI, you will essentially have a new set of options that are available to you. And one of the options is going to be called DimmFlex. And essentially what a lot of people don't understand about DDR5 is that it's quite temperature sensitive. So depending on actually the operating temperature of the DRAM, it can actually introduce instability. So what we've done is we previously had a feature that was called Dynamic OC Switcher, which meant that depending on the current and the load essentially that was being placed on your CPU, it would automatically load a different profile. So you could have like a profile for like lightly threaded, and you could have like a profile for heavily threaded scenarios, and the board would automatically switch that for you. This is kind of like that, but for memory. So the really cool part about this is going to be you'll have essentially these threshold values. So you can see right here, here's like a threshold value of 55C, and here's a threshold value of 65C. So commonly, a lot of the DDR memory, it's generally going to probably be running somewhere about like, I'd say in the mid 40s to upwards of the mid 50s. Now, depending on how hot your chassis is, your ambient temperature, the frequency of the memory, its DRAM voltage, other factors, you could see your memory start to float up, 1 degree, 2 degrees, 3 degrees, 4 degrees more, especially over a sustained period of time. So you can see like here, 65. So why do we have that threshold come into play? The reason why is because at 65, it will automatically adjust certain frequency and timing parameters to maintain stability. Because actually what sometimes users have experienced is that everything's running with stability, and then all of a sudden after a period of time they might get a crash or they might get instability, even though they initially passed maybe certain tests. The thing is that maybe when they tested, they didn't test for a sufficiently long period of time, or maybe their ambient temperature changed, or maybe they tested outside of the chassis, not within the chassis. Different scenarios to not account for always the temperature variance. The temperature variance, once it's introduced, it then actually can cause the instability. So with these threshold levels, it actually allows it to essentially revert or downclock, or inversely, it could upclock, right? It could upclock or downclock. It depends on the temperature targets, right? But essentially, it can dynamically adjust the frequency based on those thresholds. So this actually allows you to maintain stability and actually further maximize performance. So we're not going to demo this one today. I will demo this in the upcoming live stream. Today, we're going to focus on AMP2 and AIOC, and I will demo that. Because also the board that I have set up is the TUF gaming board, and the TUF gaming board does not come with DimFlex. All of the ROG boards come with DimFlex. So if you're very excited about kind of DDR5 overclocking, this could be one of those kind of big breakthroughs in terms of a technology that's very, very interesting. All right. All right. So that's one of the new items that you're going to have with the DimFlex. Okay, is going to be, excuse me, that's one of the new items that you will have on the board will be the DimFlex. Now, some people that were asking, hey, can I have DimFlex on another motherboard? So I have like the original Z790-A. Can you guys just give it to me in a UEFI update? No, because it's a combination of hardware and it's also a combination of firmware. There's even physically actually a sensor that's close here to the memory slot, which helps us to track actually the target temperature. So we need that sensor information along with the firmware tuning to be able to provide that DimFlex functionality. So it's a hardware and firmware based design. You get the Wi-Fi 7 with the Q antenna. You get the QLED with the dim detect, revised PCI slot layout. There's more USB ports on the rear, and you get the AMP2 technology. Okay. So before we go over to the Dash F, let me quickly show you just the rear I/O on the Dash A. And here I can also show you guys a little bit of a video for this board just so you guys can check it out here. So give me 1 second, I will show this to you. And if anybody wants to see it a little bit closer, I can show you, of course, a close-up of the board. I do have the board here, but I don't think it's too much of an item that we need to account for. So here we go. Okay. There you guys can see that's the Dash A. And again, great choice for those that are going to be going, I think, with a white themed or silver based, themed build, or maybe even a black and white type build. Really, really nice choice there. Okay, and here let's quickly look at the I/O. I also want to show one other kind of feature that's different here on the Z790-A. So if we take a look here at the slots, you can see 1 slot, 2 slots, 3, 4, 5, right? This one also has the rear mounted M.2 heatsink. So it's essentially what's called a dual contact design. So for M.2 SSDs that have memory that's on the front and on the back, that can be an advantage. So the TUF gaming motherboard doesn't have the dual contact design. The ROG Strix board will have the dual contact design. There's also, of course, an upgrade here when it comes to the audio. This has the SavvyTech audio design, where you have a SavvyTech amp and then a higher performing ALC 4080 audio codec. Okay. And then when we take a look here at the rear, like I said, now there's a total of 12 ports. So you got 4 ports, another 2 ports, and then another 2 ports. So 4, 8, 10, 12. Dual USB-C with 20 gigabits. Also, the Dash A now has clear CMOS. So that's something we introduced previously, but all of the Strix series, even down to the Dash A now, all have clear CMOS on them, which I'm really happy about. And hopefully you guys in the community will give us credit for that. We had to push to be able to implement that, but I'm very happy to offer that now across the board on all of these Strix series. So from the Dash A to the Dash F, Dash E generally would always have clear CMOS, but now the Dash F and the Dash A also have that. And remember, compared to the TUF gaming model, you get Wi-Fi 7 versus Wi-Fi 6E, but they both have the Q antenna design. Okay. Janny goes, silver or gray build? I would agree. It would be perfect for like a silver or gray build. Okay. All right. Next up, we'll go here to the ROG Strix Z790-F Gaming Wi-Fi 2. Okay. So let's quickly take a look here at that one. And let me bring that one up here. So what are we going to get with the Dash F? Here you're going to go. You can see You have the original, and then you have the newer refresh model. So an aesthetic update, same 5 M.2 slots, right? But no PCI Express Gen 5, still PCI Express Gen 4 for all of those. The DIMFlex technology, Wi-Fi 7, the QLED with DIMTech, PCI slot layout, and then more rear USB ports, 12 on the rear and AMP2, okay? Now, we're not talking about the differences between the Dash A and the Dash F. It is a higher end board. Some examples of like the differences, keep in mind you're gonna start to get things like here. This one has the, of course, the start button, where there's of course no start button that you would have on the Dash A, right? There's gonna be other kind of differential. Here I'm just comparing the prior generation to the new generation, so you have an understanding if you're taking a look at those two boards, right? So let me go ahead and also show you guys here just the rear I/O. So let me bring that up here. So here's going to be the Dash F. Really love the look of the Dash F, really clean. I like just a little bit of this subtle kind of gradient iridescent patterning on there that looks really, really nice. And rear I/O, you can see has actually even more ports, right? So we have right here 4, 8, 12, 14, right? 20 gigabits and 10 gigabits. So USB-C, USB-C, 10 gigabits there, right? These are going to be USB 2 ports, 5 gigabits ports, USB 2 ports, and then you also still get the clear CMOS, Wi-Fi 7, and then of course your multi-channel optical audio. So very, very stacked board in terms of its overall feature set. You'll also notice some other cool little things, like right here you can see we have a reinforced USB 3 header. I'd love to know in the chat, let me know, have you ever installed a front USB 3 connection and pulled out the housing? We have actually had people in the past that used to do that. That was part of the reason why on some of the newer boards you now see reinforced headers like this, where it's actually shielding around there that keeps rigidity to that actual push pin interface, right? So it's essentially, it's just more rigid, it's more secure, less likely for you to damage it, especially if you kind of make an adjustment or you're kind of tugging it or kind of pulling it out or something like that. That could sometimes have been an issue. I know that's why a lot of people prefer the newer internal USB-C connector as opposed to the legacy connector for USB 3, right? So that is going to be the Dash F. Okay, and I will take a quick look at the questions in a second. Let me just go ahead and bring up the Dash E, and then we'll go there. Now, one thing I do want to go ahead and touch on that you're also going to see, and actually can show you a picture of it, but we have new quick start guides, so there won't be actually manuals. Manuals you can download from the website, but the new quick start guide gives you all the core information like installing your SSDs, your physical cable connections. You can see you have this cool kind of color coded chart which shows you all the connectors on the motherboard. I'm a really big fan. We worked hard on revising this to be more friendly and easier for a lot of builders in terms of having a physical document that gives you the information you immediately kind of need when you're working on a system, but not having to go through a lot of superfluous stuff that you're never going to kind of reference, right? So again, the full manual is still available to you online, but you now have this new enhanced revised quick start guide, which is also in color for easy kind of visual layout. You get zip ties, the ROG keychain, really nice set of ROG stickers, right? An extra thermal pad for your M.2 SSDs as well comes included with the ROG Strix board, okay? Another cool thing too that some people don't realize that comes with the ROG Strix board is, remember, all of them in their UEFI BIOS come included with mem tests built into the UEFI for an easy way to test your memory, the system stability, or even making sure your memory's working correctly when you first actually power on and start your system, okay? So next we're gonna go to the Dash E. So the Dash E, of course, is the highest end board in the stack, right? So gonna look pretty similar to the Dash F, 5 M.2 slots, and we'll show the differences here in a moment. But the big thing on this one is you get native PCI Express Gen 5 M.2 SSD support on this model, okay? So that's going to be really one of the key differences between it, like in the Dash F and the Dash A and the TUF gaming board, is one, you get 5 slots, but you're also going to get that native PCI Express Gen 5 M.2 SSD support if you want that feature set, okay? All right, and you can see again, 4, 8, 12, right, 14. So 20 gigabits, dual USB-C, 10 gigabits, 5 gigabits, USB 2, clear CMOS, Wi-Fi 7, and that multi-channel audio on there. Let me go ahead and bring up our image here for essentially the differences between the Dash E, between generations. And here you can see essentially the prior Dash E and the new Dash E. Let me know what you guys think. Did you like this design here, or did you like this design here? They both look really cool. I kind of liked this little bit of this soft diffuse design, but the new kind of dual pattern here where we have a little bit of this matte finish and then a little bit of kind of this subtle glossed finish, I think looks really slick. It looks really cool. I think they both look really nice. It's a different design, but I thought this was kind of interesting. So what's new compared to the prior Dash E? It's, of course, a revised design aesthetic. The VRM has been further upgraded. Again, on every board, even the TUF gaming board, the VRM is not a limiting factor. You can run a 1300K, a 1400K overclocked. We're going to show that in the ASUS AFC demo that we're going to be doing in a little bit. 5 M.2 slots, right, that you're going to have there. Remember, one of the slots, so you get PCI Express Gen 5 support. You get the DIM Flex. You get the Q antenna and the Wi-Fi 7, the QLED with the DIM detect, the revised slot layout. More USB 10 gigabit ports is going to be on the rear compared to this model. So you get more of that. And then 3 internal USB 2. So if we actually take a look down here, you can see here 2 USB 2 internal headers. But here you can see 1, 2, 3. So 2 headers, 3 headers. So for those of you running lots of different kind of supplemental controllers, different items, having those 3 headers can be really advantageous, okay? And another difference that some people kind of ask about is this little switch right here. I can show it to you on a board if you guys want me to show it to you. Actually, let me go ahead and do that. I'll grab the, I think I have the, is this the Dash F? I'll grab the Dash E in a moment here, but I'll show it to you. But this is actually what's called the PCIe alteration mode switch. So that switch, it's pretty cool because what it allows you to do is if you're using like a PCIe riser cable in a system, so you're doing vertical mounting, one of the issues that can present itself is you have maybe like a more marginal riser cable. Maybe the cable might have an issue in terms of stability, reliability, signal transmission, things like that. In the past, to kind of resolve that, you would have had to potentially remove the whole cable from the system, maybe then had to go to like internal graphics, maybe made a toggle in the UEFI BIOS to go from like Gen 4 to like Gen 3 or something like that. Now with that physical switch, you can just toggle the actual PCI Express operating mode with the switch. So it's a really, really nice kind of more easy and convenient way to be able to make those adjustments. Let me go ahead and I think I can show it to you on the Hero. I'm going to show you the Hero. Oh my gosh, this box. Look at that. I love this box. It says Z790 Maximus Dark Hero. And then it says Dark Hero on it. It's very, very cool. Okay. You get your reps in here with the Maximus board. All right. So right here, I'll show you that little switch. And I see there's a lot of questions that's popped up in the chat, so give me a second and I'll jump into the chat there and we'll take a look at that, guys, okay? So here, let me focus that for you guys. Sorry, one second. Okay, so if we take a look down here at the bottom of the motherboard, right there, that switch is that PCIe alteration mode switch. So that's on the Dash E. It's also here on the Maximus board, but you can see right there, it's got actually 3 levels. So I can click in once and then click in another. So that's stage 1, stage 2, or stage 3. The other cool thing about this switch, outside of doing the PCIe operating mode for the, let's say the attached riser cable or the slot, is that you can go ahead and use this for fan controls too. So you can go into the BIOS and you could switch this instead of working for PCI Express, you could have it be for fan control. So you could have it like low, medium, or high for fans. If you had all your fans connected here, you could actually use this as a basic kind of like fan controller, if that makes sense. That's kind of cool, right? All right, so that is going to be the Dash E. Let me go ahead and see what kind of questions we got here. And we'll jump into this. Okay, so that is going to be the Dash E there. All right, so Dark Hero, the cover is so stealth Spider-Man look. Yeah, I love the way that the Dark Hero looks. It looks really, really cool. Okay, can't add that if there's no connection. I'm not sure. So Thunderbolt 4, A's Jeep 26. Thunderbolt is on the Maximus boards. So yeah, so if you want to be able to essentially have Thunderbolt connectivity, Remember that all the boards will pretty much have essentially a header on them. So if you wanted to be able to go ahead and add Thunderbolt, you can do that, even down to the TUF gaming model. So again, here, if I kind of go to, this is the dash F, right? If we go all the way down here, you'll see right here, it says TB USB 4 header. So there's a Thunderbolt header. You can buy our Thunderbolt header and add that. So the board already comes with 20 gigabits USB on there with tons of connectivity. If you wanted Thunderbolt though, and you want USB 4, you're going to move up to the Maximus board. So either the Dark Hero or the Formula, they both natively have Thunderbolt USB 4, right? But any of the other motherboards, you would have to add the Thunderbolt add-in card if that's something that you found that you wanted to be having, if you wanted to have that specification. Okay. Zenru, Zeril X11. I love the print manual, but saving paper is good. One day I'll get JJ to autograph my Glacier manual. I got you, man. If we ever are at an event and you're there, I got you. All right, sounds good. All right. I like the ASUS UEFI and mem tests. Yeah, thanks. I agree. That's a really, really nice feature set in terms of having that functionality, right? Okay, so I think that's all the quick questions that I saw there. So let's go ahead and now round it out with the Maximus boards, and then we're going to go into the demos, guys. All right, guys. So let's go ahead and show you guys here. So we're now going to move into the flagship series, so the ROG Maximus models. All right, so let's do it. So this is, of course, going to be our flagship series. This is where, of course, we have the kind of the best of the best. This is what we bring to the table for those that are kind of really looking for the overall kind of I'd say the best feature set in terms of the motherboards that we have to offer, right? If you are really looking for the boards that are going to offer you the most features, the most functions, right? The most premium design elements, and that's what you're going to want to be looking for is in terms of the Maximus series, right? So as you can see, we're going to have 3 refreshes on the Maximus line. So we've got the Dark Hero, the Apex Encore, and the Formula. These are all ATX-based motherboards, so none of them are EATX. For anybody that's asking, no, we don't have any refresh for the Extreme. So there's no Z790 Extreme refresh. There's no Mini ITX refresh. There's no Micro ATX refresh, okay? These are the 3 Maximus series boards that we have. The Dark Hero, the Apex Encore, and the Formula, okay? And yes, there was some color swapping, right? So the prior Apex was, of course, white. Now the Apex has gone back to being black. All the other Apexes were all black. Partly that was also due to now that we reintroduced a white board, right? Of course, on the high-end side with ROG Maximus, with the Formula, of course, being offered in white. And in my opinion, it even has a more bold white aesthetic because the shroud is more kind of consistently white as opposed to even having a white PCB, because pretty much once you put in those white dims, everything you're pretty much seeing on the board is pretty much white. One thing I did forget to note, guys, that's cool on the Dash A, even the antenna that comes with the Dash A, it's a white antenna. It's not black. So even the antenna is actually white, which is it's a little subtle thing, but it's kind of cool. All right, so let's go into the first one. We're going to go into the ROG Maximus Z790 Dark Hero. That's going to be coming in at $699. Okay, and let's go ahead and take a look at it. Well, I brought out the board right there, so I guess I could show it to you right here before we go into the images, but there it is. So shiny. It has a really beautiful look to it, right? That polymo display looks fantastic, right? When this board is just in black, where there's no lighting, that it just looks really, really clean. All of the boards are like that on our Maximus series, right? There's no actually cybertext font. There's nothing like that. They have a really premium and refined design ID. But again, they also have that elevated aesthetic that if you do add in the lighting, they will have definitely a really nice look if you do want to have lighting on the board present. Okay, so let me go ahead and bring up here my images for kind of what's new between the old Z790 Hero and then the new Z790 Dark Hero. Okay, so the first one is going to be right here, is you're going to have the aesthetic update. There's a change, of course, in the ID design. I'd say it's a little bit more subdued. The prior one was already very, very refined. And again, here you have the RGB lighting, but they both have that same look that when there's no lighting, that takes on almost like a chrome silver-like appearance, which looks really, really refined. The bottom section, though, does have a little bit more of a subdued design, where here this kind of has this nice you know, kind of depth kind of design to it, with silvers and kind of white highlights that are there, versus here you had a little bit more of that pixelated kind of design display, right? 5 M.2 slots, though, this is a really big change. This board only had 3 slots, and then you had to have the Hyper M.2 add-in card to be able to get a total up to 5, and it didn't have native Gen 5 support. Here, this board has 5 slots all on the motherboard, and it includes native PCI Express Gen 5 M.2. Now, they also both have PCI Express Gen 5 dual slots. So this is a Gen 5 slot, and this is a Gen 5 slot. Now, some people ask, well, why would you do that when SLI or Crossfire is no longer an option, right? Or NVLink. And part of the logic is that it gives you as a builder more flexibility, more choice, whether you want to use like a higher speed add-in card. One, you have an option for that. Or you could actually put your GPU here. So yes, the GPU would run at by 8 versus by 16, but again, even a 4090 won't be constrained. The advantage of that is physically it will just have a different dimensional layout, right? It will look different, you know? So maybe if you want a little bit more of this design visible, that is kind of cool, where you might have this part of the board kind of be more visible, and then you could go with that single slot design. That would be kind of something cool and interesting if maybe you did a water-cooled oriented build. That is an option. You have the DIMFlex design, Wi-Fi 7 with the Q antenna, QLED with the DIM detect. There is a change in the SATA ports, it's less, but keep in mind you're also getting more M.2. So here you had 6 versus here you had, of course, 4. AMP2, the reinforced USB 2 header, and then you also get the premium Intel Unison based software, which is actually a pretty cool software suite. I also make note here that don't forget that some of the upgrades, there's lots of upgrades on the Maximus series compared to the Strix series, and if you guys want to know that, again, I would recommend checking out the prior stream where we dive into all of that, because there's a lot in there, but pretty much everything is upgraded. You're going to get Thunderbolt, you're going to get dual PCI Express Gen 5, you get differential dye sense voltage monitoring, so it's a more accurate form of voltage monitoring. The power stage delivery is even higher end. It has higher performing inductors, higher performing capacitors, higher informing power stages. Right? You're going to have a higher end PCB and that low loss PCB design that's going to be on there. You get dual front USB 3 on the board. You get the audio DAC that's been improved upon with an ESS Saber DAC and amp that's built on board. So there's a lot of stuff that goes in that it's not just here. Remember, we're only comparing Maximus prior generation to this. We're not talking necessarily about the difference between the boards. Okay. All right. So that is going to be the Maximus board. Let me go ahead and show you guys the rear I/O. And I'll show you a quick kind of this little visual there of the board close up, just so you guys can see it. So here you can see the board. The board has, of course, a backplate on it, which helps to mitigate torsion. It also serves a little bit as a heatsink because it does make contact with the VRM. And here's your rear I/O. You're going to see no USB 2 ports, where like some of the Dash 8 ports you saw that you might have had lower speed ports. All of these are high speed ports. So 5 gigabits, 10 gigabits, 10 gigabits, Thunderbolt, so 40 gigabits, 10 gigabits, 10 gigabits there, right? So overall, all high-speed ports, 2.5 gig networking, Wi-Fi 7, and then multi-channel line-level audio, clear CMOS, USB OS flashback, and then an HDMI, right? So that is going to get you covered there for the Maximus, all right? Let me go ahead and just see there if we have any questions, and I'm going to quickly show you guys the design on the Polymo display, because I think the Polymo display looks really nice on this board. Okay. When will USB 2 go away? Well, there's no reason. USB 2 still almost all your peripherals, right? So keyboards, mice, microphones, you know, printers, scanners, they're pretty much all still using USB 2. There's a lot of interoperability and compatibility items to keep in mind. There's also cost. Scaling everything to be like a USB 3 based chipset would actually make devices even more expensive. So there's still value for USB 2. I don't see it going away for a very long period of time. There's not actually any reason to remove it. You could even argue there's still merit for even serial-based connections, right? Because of their superiority in terms of a continual polling-based design as opposed to an interrupt-based design. It still has value, right? All right. So let's go ahead and take a quick look here. The Dark Hero just lit up. You can see that Polymo display. I think it's got a really cool design. Now, keep in mind, you can, of course, go into the Armory Crate software and you can tweak, you can change, you know, colors. It's actually what's called a dual layer design. So there is actually some different patterns that are in there. So this is kind of like an in-between. The Strix board has a more basic kind of just ROGI logo, which just lights up. So I can actually show you guys the difference here. So give me a second. So here, if we look at the Strix, that's the Strix, right? And if we actually show you guys right here, let me see if I can put them kind of side by side. But you'll see the design difference. So one's quite a bit more kind of elaborate than the other. And then, of course, the Extreme boards had a much more advanced lighting design because they actually have an anime matrix, which is a fully customizable display. So if we kind of, let's see here, if I can do these both at the same time. Yeah, so you can see right there, that's that ROG Eye. It's got a really just nice, clean, diffused design. But of course, when you compare that to the Polymo display, the Polymo display is quite a bit more vibrant, and it also has a more dynamic design because there's a little bit kind of more, there's animations, right? There's variants, and there's a dual layer design, so this can be customized more, right? So that's the Polymo lighting design, and that's the ROG Strix lighting design. So there's a bit of a difference between those two. Not just a bit of a difference, actually it's a very noticeable difference, right? So that's going to be your difference between the Polymo lighting and then your standard kind of RGB lighting design that's on the Strix boards, okay? Okay, and that's pretty much it for the Maximus that I think I wanted to kind of show. I don't think we need to worry about too much other things. Like I said, if you guys want more stuff, you can check out the full in-depth live stream. You'll see grouped fan headers, which is more friendly for, of course, water cooling enthusiasts and nicer for kind of cable management. Debug LED, still 3 RGB headers on there. You've got, of course, the start button, the flex button, which you can, of course, change to different items. You have still that prior design that we had, which, of course, the USB-C with the supplemental power can support up to 60 watts of power. Of course, the Q release for the PCIe ejection. Of course, those M.2 SSD heatsinks. All the Maximus boards, you're going to actually have three dual contact designs. So there's multiple dual contact designs that are going to be on the board compared to, remember, like on the Strix, you only had one dual contact design, right? You're also going to have the dual front USB 3 headers, so one USB header here, another 3 USB header there, and that internal USB-C. You get the water cooling zone headers right here, which is going to be nice for input and output and flow monitoring for loops, the PCI alteration mode switch, and the dual PCI Express Gen 5, and then, of course, the Supreme Effects audio design. Okay? All right, so that is going to be the Maximus Dark Hero. Okay, so let me put that one away, and we're going to go to the Apex. So let's go over here. Next one we're going to have is going to be the Apex. The Apex is actually a little bit less. Let me go ahead and actually make a quick change to that. So give me 1 second here. There we go. So the ROG Maximus Apex Encore comes in at $649 versus the Dark Hero, which is going to be $699. Okay. Let me go ahead and put this Dark Hero away. I'm just going to put this Dark Hero away, and I will show you guys the Apex. And then we're going to get, we'll just do a quick touch on the formula, and I'm going to go into the demos, guys. Okay, let me grab the Apex here. All right, so I've got the Apex here to show you guys, and let's go ahead and bring this one up here. So let's bring this up here. So the Apex, of course, is going to be really focused for those of you that are looking for, of course, the kind of board that's really focused at overclocking, especially DDR5 based overclocking. It does have numerous upgrades that those still make it a really great choice for an enthusiast leveled build. I really like the kind of the more stylized design that the Apex board brings to the table, as opposed to kind of the traditional boards. So it does have a little bit more kind of a very kind of design, which I think is kind of cool. I also really love the DIMM.2 design, especially for water cooling enthusiasts, because you have to think about it. Let me know in the chat if any of you guys have ever built a custom loop. One of the big disadvantages if you put a loop, especially if you have hardline, which is part of the reason why I don't like hardline builds. I build all my water cooled builds with a soft tubing. Is that if you wanted to add like something like an M.2 SSD and it's underneath a slot and you don't have access to it, right? You literally have to remove the whole loop, right? You've got to, drain your loop. You got to remove your graphics card, access to that, take off the M.2 heatsink, do all that, then replumb the loop, get everything back up and running. It's a significantly more time-consuming process. Where literally, if you have that DIMM.2 add-in card, you've got two M.2 SSDs. You can literally take that out of the box, put those two M.2 SSDs or that one M.2 SSD, put it on there, attach the heatsink, and you're done, right? So within 10 minutes, you can be up and running and you didn't have to change anything in your loop. That's worth a huge amount of value proposition, in my opinion, is having that level of flexibility. So even from a non-overclocking centric functionality for just a pure enthusiast build, it has some really cool value proposition, especially for, I think, like I said, water cooling enthusiasts, right? You're going to have, of course, our highest performing VRM design on this board. You have a brand new cool design attachment right here for actually a 60 centimeter based fan for auxiliary airflow for both the M.2 SSDs and the DIMM.2 card and your DRAM. And I'll show you that a little bit more, but here you can actually see how it mounts onto the board. It's pretty slick. And you do have full control for this. So it is fully controllable within the UEFI as well as within the Fan Expert software. So you can go ahead and customize a full fan curve for it if you want to. And then also here you can see on the rear, you've got clear CMOS, USB BOS flashback, two, of course, legacy ports with serial and mouse, all high-speed ports, so 5 gigabits there. Then you got 10 gigabits, so that's 8 ports, and then 10 ports. So a little bit less than what you have on the Dark Hero, and there's no Thunderbolt, but you still get 20 gigabits, and then 2.5G, Wi-Fi 7, and then multi-channel line level audio, okay? So let's take a look here at actually what is the difference, though, between the two Apexes, so between the prior generation and between the new generation. So here you can see we've got the Apex Encore and then the Apex. So of course, the one really right off the bat that's really easy to understand is one was white and now one is black. Here you can see there's another difference in terms of the M.2 SSDs. Like I said, all of the Maximus boards now have 5 M.2 SSDs. So here, that's an upgrade. And you also have native PCI Express Gen 5. So this one supports native PCI Express Gen 5. So 3 on the motherboard as far as M.2 SSDs, and then 2 on the DIMM.2 add-in card. You get that DIMFlex technology. You get Wi-Fi 7 with the Q antenna, the DIMM detect feature, the PCI slot layout. I really like what we did with the PCI slot layout, which also makes sense because keep in mind here, if you had like a 4090 here, you had the M.2 and it was still accessible. But this design, you can see you can have the graphics card and then still here if you wanted to have something on top, like maybe a capture card or a sound card or maybe something else, you have some flexibility. You can use that top slot. So I actually like this design layout. This is also like the Hero where you have, of course, dual PCI Express Gen 5 slots. So that gives you flexibility. 4 versus 6 SATA, so this is 4 versus 6. AMP2 technology, the reinforced header, and then the Intel Unison software as well. So that all comes in the Apex Encore, okay? Let me go ahead and show you guys a quick look at the board and see if there's any quick questions right there. I like the Z790 formula. I wish I could get it started with 10G Ethernet. Yeah, so we actually had 10G Ethernet on the prior model, and we did spec it differently this model with only 5 gig. If you still wanted really 10G, we still have the ProArt model, or of course you can get just a 10G add-in card. We do offer a 10G add-in card, which you can just drop into a slot, okay? A's Jeep says, giving some feedback to say that you want to remove covers. Yeah, that's interesting. We have evaluated that. Of course, I think we have the most history in the industry when it comes to kind of innovating kind of easy PCDIY designs. We have evaluated some magnetic covers. We necessarily haven't felt that they've been the best implemented, so they still can sometimes be a little bit wonky. We actually prefer the adhesion consistency of actually using the screw. Now we have made it easier because that screw is what's called a captive screw. So that means that when you remove the screws don't come off the heatsink. They're actually permanently attached, so that does make it very easy. Let me see if I have one right here. Yeah. So right here, this is one of the heatsinks like from the TUF game, and you can see right there the screws. There's one screw and there's another screw. They don't come off. I actually am entirely fine with this design. I can see how for some people it might be a little bit easier, but to me, I don't think we need to go with like a magnetic approach, but it is something that we'll be evaluating. Of course, we designed and developed the quick latching mechanism on M.2, and we saw every other competitor in the industry copy that same design, right? So it is something that we are evaluating, but right now, I think from an adhesion standpoint, temperature standpoint, we still find this design is overall the best, and we prefer this design. But we're going to continue to evaluate it, and maybe in the future you might see something that might be toolless from us in that respect. So I would not say no. It's something that we'll continue to evaluate. Okay. So let's go ahead and quickly take a look here at the Apex Encore. And I don't think I need to take out the dim.2. Do I need to take out the dim.2 for you guys? Do you guys need to see it? Why don't you let me know. If you want to see it, I can show it to you. But I think probably most of you have seen it, so you're probably aware of how it works, right? But I know we still get questions about it. We still get people's like, why is that? What is that? What is that slot on that motherboard, right? So let me go ahead and get that there. So here's the Apex Encore. One of my favorite designs. I really love this kind of little lighting underneath there, so it's almost kind of like this little bit of this kind of subtle way to kind of just show the lighting. It makes it feel to me like almost like a little bit of a sleeper, like a kind of inherently kind of powerful vibe to it, like an engine that's kind of running. It's pretty cool. I do really like this lighting design shining through the heatsink. I think it's pretty cool. Okay. So you can see, of course, ultra performant VRM assembly. It's our highest in VRM design in terms of the power delivery for the inductors, the MOSFETs, the power stages, because they're power stages, so they're not actually a two-stage, right? It's a power stage. So from of course, the low-profile capacitors right there to, of course, the inductors to the power stages. This is the highest performing VRM that we have. PCI Gen 5 support. This is, of course, has an integrated heat pipe, just also like the Dark Hero. They both have full extended heatsink assemblies that go into the I/O section, and also actually have a heat pipe design. Keep in mind that the VRM on this model, though, doesn't have any support for the iGPU, so there's no display out. So if you want to be able to run the iGPU, you want to pick the Dark Hero, you want to pick the Formula. This one does not have support for the iGPU. 2 DIMM slots, because of course it's an improved signal topology, right? There's less what's called signal reflection. Ultimately, this is just better for high DRAM scaling. As you guys know, the Apex has consistently been the world record holder for CPU performance, not only for socket 1700, but for DDR5 overclocking. We have consistently sent benchmark after benchmark after benchmark after benchmark after benchmark. We have broken it. The Apex has been the leader in that respect, and we just broke the world record again. Pretty amazing stuff, right? Actually, I think over 11 gigahertz. Absolutely just insane stuff. So that's your DIMM.2, which can of course support 2 M.2 SSDs, right? You've got all your supplemental course connectors right there as well. I'm not going to get into some of the more esoteric connectors for the overclocking stuff, so I won't worry about that. As we scroll down on the board right here, you got your PCI Express ejection right there. You also have the 60 watt charging support on this model as well. And then when you move down to the bottom, pretty much part and parcel, right? So dual contact design also for the M.2 heatsinks. I won't remove the heatsink, so you have the alteration mode switch as well. One thing that I do love though on the Apex that we don't have on the Formula is this little guy right here. This is the dual BIOS switch. You'll see actually that little LED changing. So one of my favorite things is actually having 2 independent BIOSes, so I can actually run 2 different BIOS versions for testing. If I want to run different kind of overclocking parameters, I can do that between 2 different builds. Now keep in mind that with our UEFI BIOS, you can actually have multiple profiles for one BIOS, right? So you can actually have one profile for stock, then another profile for overclock, another profile with a different set of overclocking parameters, and you can load in between those profiles. But this is actually true 2 dual independent ROM chips, so you can actually have have two entirely different ROM versions loaded. So you could have, like, let's say version 1700, and you could have version 1500, and you could toggle between those two. So that is going to be a key difference that none of the other boards are going to offer you, is that dual BIOS design. All right, so that is going to be the Apex. All right, so very, very cool board on that side. And let me quickly go ahead and see. All right, again, right here, that's just a quick recap of the design differences. Let me go ahead and see if there's any quick questions that might have came up right there. So the Tech Allen goes, I've built a lot of Dark Hero and formula-based systems units, but the Apex haven't touched one. Hoping to build with one Apex in the future. Yeah, man, Tech, you do some of my favorite builds. You have a really clean layout design, really beautiful. Of course, a lot of great water cooling work that you've done. So I would love to see what you would do with the Apex. And I'd also even love to see what your feedback is on having access to, like I said, that DIM.2 based design where the formula and the Hero don't have that. I don't remember if you've done one with the Extreme, but of course the Extreme boards do have the DIM.2 add-in card, which again just gives you a little bit easier flexibility to easily remove or add in drives, even once you have your loop all plumbed and all set up. So it's a nice level of flexibility. Again, for a water-cooled base build, it is also going to be advantageous for those that really kind of want to push frequencies. It's going to give you that best experience possible, right? What is all that tan small marking looking like unfinished PCB? Oh, that's actually my PCB board. You're confusing the board with my PCB board. So here's the motherboard. So I'm going to remove the motherboard. That's my PCB board. So I have PCB blanks. These are blanks of different types of PCBs. And then I have little risers, so I can use these as little things to put my motherboards on. Okay. Yeah, we gave these away to different overclockers and to people in the past. I might be doing stuff maybe in the community again in the future to maybe give away some PCB blanks because they're kind of cool. And it's just something different, but it's not the motherboard itself. It's just their PCB blanks. Okay. All right. So that is going to be the Dark Hero. All right, let me put the Dark Hero away, and we're going to jump and show the formula. And then we're going to do some live overclocking. We're going to do some ASUS AIC. We're going to do some AOP AMP2 demos. All right. All right, I just muted that for a second, guys, because I wanted to make sure that you hopefully didn't hear too much bumping there as I went ahead and kind of bumped my table and moved these items around. So give me 1 second here to grab this board. Oh, and I think I showed you guys the image, but here's just a quick visual. That's that new quick start guide, that color coded quick start guide. You can see right here, it's just really easy where it kind of visually maps everything out. So on the TUF gaming board, it also has a similar quick start guide. It's not in color. All the ROG Strix and the ROG Maximus boards, though, do have color versions of the quick start guide. You got helium for the overclocking? No, I mean, I thought about though maybe if maybe for like towards the end of the year, maybe we could do something a little bit fun, maybe crazy. I don't know if I would want to do it with of course with LN2. I've done a little bit of extreme overclocking in the past, so it's not that I haven't done it before, but it's so kind of extreme that it's somewhat not realistic for you guys. So I think it would be kind of cooler maybe to do something kind of crazy where maybe either we do like a really kind of crazy big custom water cooling, maybe overclocking demo, or maybe we go to something like a chilled loop, right? Or maybe even dry ice. Dry ice is really easy and it's very inexpensive and doesn't have the same super complexities that LN2 does have, so that maybe even if somebody wanted to try that, they could get a basic pot, they could get some dry ice, and they could have some really low temperatures, be able to see much higher frequencies, and it's kind of like a cool gateway. I mean, I did a dry ice overclocking for, well, like 3 to 4 years. It was kind of fun. Eventually, I kind of just stopped it, and just kept most of my overclocking pursuits focused on just regular, pretty much air and water-based overclocking pursuits, just because, like I said, they're the most realistic. But There is definitely something about that extreme kind of course experience of just being able to go for the absolute fastest performance, the absolute fastest clock speeds, and having the absolute best temperature reductions, which of course for that you're going to need liquid nitrogen, or you're going to need liquid helium, right? And that's of course what, you know, are a lot of our performance overclockers, whether they're on our RG team or people that we work with in the community, that's what they're focusing on to be able to break those world records, right? So pretty cool stuff. How's that 8000 he's that 8000 OC going, right? Yeah. Well, 8000 OC is not that complicated. You know, I mean, you have to have a little, just a better quality IMC. Like I said, you know, I had to definitely been through a few different CPUs to be able to get a CPU that could reliably hit 8000 MT, but I have been able to do 8000 MT. I've done it on the Apex board. Actually, I've even done it on the Hero board, on the Dark Hero board. I have done 8000 MT, but again, not all of your IMCs are going to actually be that good in terms of being able to hit there. All right, so give me 1 second here to get the formula, guys, and we'll round that out. So next up here, we're going to show off the formula. So this is going to be the ROG Maximus Formula. This one is going to be coming in at $749. So this is pretty much like our flagship in terms of our, I guess, our highest end board. I guess, though all the Maximus boards are, of course, all high end, though, right? All right, so there you guys go. It's got a beautiful, of course, design where you got that full white shroud that's on here. There are a huge number of changes between this and the Z690 formula. So we're going to recap the changes that exist there. But it looks kind of pretty similar, but there's a lot that's different from everything from the hybrid, of course, VRM and water block design, right? The heatsink and the water block design, to, of course, the aesthetics, to the PCIe topology, to the feature set. There's just been a massive number of changes. So we're going to go through those design differentials, okay? And again, when you guys, I was talking about, even the antenna that comes with it is, of course, is a white antenna. And even the cool little new updated flash drive that we have is also white. So that's kind of cool too. And from the rear I/O, we'll just quickly show you the rear I/O, but you can see 4, 6, 8, 12. So a total of 12 ports, very similar pretty much to the Hero. 2 of these are going to be Thunderbolt USB 4, so 40 gigabits. Then you got a third USB-C, so 3 USB-C. And then you've got your 5 gig and your 10G ports and your 40 gig. 5G in terms for Ethernet is supposed to 2.5G, Wi-Fi 7, and then the multi-channel line level audio. But let's go and take a look here actually at the design differences between this and the Z690 formula. Although I don't think really anybody would have to upgrade between the two boards, right? Because again, all Z690 do readily support this, okay? So if we take a look here, Z690 formula to Z790 formula, okay? You'll see that there's an aesthetic change. It looks pretty similar. The lighting design, though, is different. This section no longer has a lighting design in the bottom section, so this is all just white and silver, okay? The M.2 slot configuration, though, is quite different, where, again, you now have 5 slots that are on this board, with this one also having native PCI Express Gen 5. The OLED Live Dash display is the same. It's a 2-inch OLED Live Dash display. Okay, so that's this guy right here. That can display voltages, clock speed, fan speeds, flow monitoring information for your loop, or custom animations, things along those lines. You have more rear speed, high-speed USB ports that are on here. So there's more USB ports, like I said, that are essentially high-speed ports, okay? The DimFlex design, Wi-Fi 7 with Q antenna. This hybrid chill VRM heatsink block has been entirely redesigned, so it's now full copper, and the actual electroless nickel plating application has actually been also increased in terms of the amount that's actually applied there. So again, you don't have to use this in a water-cooled configuration. You can entirely run it passive. So that means you could just run it as is. Even if it's overclocked, it's not an issue. The power delivery is very efficient, and that heatsink assembly is going to be able to dissipate the VRM itself even when it's under load. So yes, if you want to integrate it into loop, you can integrate it into a loop, but you do not need to integrate it into a loop, okay? You also had a change in terms of the ESS Saber DAC and amp, which is now it's the ESS Saber 9218 DAC. Same thing, because we have the more M.2 that we take a revision where we have a drop down in the SATA ports. This has 4 versus 6. It has AMP2, the QLED with the dim detect, and then also the reinforced USB 3.2 header and the Intel Unisom software, okay? So those are going to be all of the kind of updates compared to the Z690 formula. So there's a lot that's been changed there. I didn't note the networking spec differential, but this is also a networking spec differential, right? This one has 5G connectivity, right? And the prior actually had 10G connectivity. So there is one additional difference in that respect, okay? Let me go ahead and see on some questions right here. So first is going to be, is the formula limited? Yes, actually the formula is always limited. It's never not a limited motherboard. So as far as like the length of time that it's available, it can vary. Sometimes it can be available for a little bit longer, sometimes for a little bit less. It just depends on how quickly it sells through the channel and how many kind of follow-up batches of productions that we have from the initial kind of launch allocation. But we do tentatively kind of mark it as a limited production. So like the Apex Encore is limited production. The Formula is limited production. The only one that's not limited production that pretty much will reside through the entirety of the duration is always the Hero model. The Hero is always kind of persistently available within our model. Of course, here we're refreshing over into the Dark Hero, but you'll still continue to probably see the Z790 Hero for a while as well. So yes, the Formula is going to be a limited production model, okay? Tech Allen says, oh man, that silver ROG logo makes the Formula more good looking. Yeah, we'll go ahead and take actually a close-up look to it, but I think it looks really, really nice. It just gives it a kind of a little bit more of an elevated premium vibe. And especially, again, if you go with a single slot card, because you can go into the top or the bottom slot, you can even show a little bit more of that ROG eye off, right? The Formula could have been a nice upgrade from the Extreme. Not really, because the Formula and the Extreme are different models. But of course, if you compare it to the Extreme, it does have some new stuff that the Extreme doesn't have, right? But again, they are different models, because like the Extreme also has the Anime Matrix, it's EATX. The prior one came also with things like the Voltician. It had the DIM.2 add-in card. So they're inherently just different models, right? The OLED helps you see an example if your build doesn't post. Yes, I mean, all the boards already have the QLED technology, but if you like having an additional readout of information, the actual Formula actually has both. So you still have the traditional debug display readout up here, but then you also have a debug readout that's also displayed here. And it's cool because it does give you kind of supplemental information, like if you're using like a USB BIOS flashback and it says like certain firmware is updating, and actually it will display that to you. So it is a nice kind of visual reference to see additional data points within the build, right? I have the Ryujin 360. Can you point out where the AIO cable connects? If the settings next to you, I have in the settings next to you, since I have the Z790 Hero. Okay. Yeah, so for the Ryujin, it would still be the same connections on any one of the other motherboards, right? So the Ryujin 3 already has the magnetic ARGB daisy chain cables. So in terms of the fan headers, let me grab the Formula here. Where did I put it? Oh my goodness. Okay. So you said, you said that actually you wanted to point out on the Hero, but yeah, I mean, I can show you, but it won't really be any different in terms of the actual connectors for the Dark Hero. You're pretty much just going to connect to the AIO pump header and then the USB. So on the motherboard, you're going to have a USB header that you're going to use, which is going to be usually pretty much one of these down here on the motherboard, right? And then your fan and your ARGB is going to connect probably to the CPU fan header that's going to be up here, and then probably like an ARGB header here, right? But since they're magnetic and daisy chain, you only need to connect one cable for all three of the fans, right? So all three of the fans, they'll just have one cable that connects to either the end or to the left or the right fan, and then you would just run that to one CPU header and then to one ARGB header, your USB 2, right, and then your pump header, and that's it. So very, very simple. The AIO pump header, you can reference that in the manual. For different boards have the AIO pump header located in a different, in a different location, but that's it. It's very, very actually simple to be able to go ahead and connect it. Oh my goodness. This Formula, of course, even weighs more than the Dark Hero. All right, so here you guys can see just a little bit of a closer look at the Formula, and we'll put it under the secondary cam, but you guys can see right there great looking board, and it's nice to put it up against the Prime board. The Prime is one of my other favorite boards that we have in terms of a white themed based motherboard, but absolutely just stunning design. Looks fantastic right there. Okay, so let's go ahead and take a closer look at it here. Are these all available for order? Yes. Pretty much everything should be online right now. I think they're all available listed right now in the ASUS store. I don't know if every of the channel partners, so like Amazon has them all listed right now, but again, for any other channel partners, it should probably be within about the next 5 to 10 days. But I think on the ASUS store, everything should be available right now. As far as the TUF Gaming, the ROG Strix boards, and the Maximus series, they should all be online and available. Okay. So let's go ahead. Oh, wow, that board is so white. It caught my exposure for my camera there. So let me go ahead and tweak that. All right, so there you guys go. So here is the Formula board, okay? So you can see that really nice, just really clean design. Of course, this metal core top cover, there's a little bit of gloss. That's just actually because I haven't even done the peels off this. So keep in mind that it's actually a little bit more of a matte. It doesn't necessarily have a gloss to it. So do be mindful of that. I just haven't done the peels. Actually, I should have saved that. I could have probably made a good video on that. But there you guys go, right? But you've got the nice, of course, diffuse lighting as we always do. Of course, these are the caps for the water cooling inlet and outlet. You do not need to, of course, remove those or touch that. Again, you don't have to use water cooling on this motherboard. The hybrid chill design is a heatsink and it is a VRM water block. And again, for this generation, it has been revised. This new in-house design that we have right here, it's full copper, and then we've increased also the electro-nickelus plating that we have to the actual copper block, okay? If we go ahead and pull up the board right here, you're going to see that really nice big OLED live dash display. That flicker is just from the camera at the frame rate, but you don't see any flickering in person. Right now there's just the default animation, which is really cool, but again, you can have all kinds of different display points that show up there, from, like I said, voltages to temperatures to fan speed to flow monitoring, all kinds of stuff like that. All right, we go ahead and pull up a little bit further right here. You're going to see the PCIe ejection right there. You've got your supplemental power for, of course, the front USB-C, which supports up to 60 watts. There was, of course, the retry, the start, and the flex key buttons that are also on this board. The debug LED, the grouped fan headers, just like the Maximus board. And then when we go to the bottom, that really nice design here, where you can see you've got the dual PCI Express Gen 5, that really nice design there with no RGB lighting for this generation, but just a really nice clean ROGI with the silver and the white accenting, which I think looks really polished, really clean. The PCI alteration mode switch down here at the bottom. Reinforced USB 3 header, your 3 ARGB headers, your water cooling zone that's also going to be here. All right. Let's see. So I got some feedback right there. Wow, the Formula is stunning, gorgeous, beautiful board. No, the board is so bright. JJ needs shades. Yeah, it does. It's definitely the gloss is peeling. Yeah, super clean, cybernetic looks design. Yeah, I would definitely agree. Has ASUS ever thought about making a motherboard with a bi-PCB? Yes, we already did. We did that actually just in the prior generation, the Z790 Apex that I just showed. It would have a white PCB. The Formula looks amazing in a water-cooled build format. Just saying. Yep. And I really wish it had a YVCB. I don't really think it just adds more complexity and even cost to the board unneedlessly, in my opinion. So definitely, I know some people that would like it, but you can't really almost even see it, right? Because the reality is, once you even put that block, you put the memory on there, there's just a very small part. So to me, this board actually looks more white than the Apex board, which actually had a white PCB. To the user that was asking though, have you done white PCB? Yes, we have done white PCB. That was, of course, here with the Apex, where you can see that it had a white PCB, right? But white PCB is definitely challenging. It actually generally is going to be more costly to produce. It also has yield application issues. There's even sometimes some performance considerations that you have when you have different colored PCB that you have to evaluate. So there's a lot of different kind of factors that kind of go into it. All right. So that is going to be the Formula, and that wraps up all the boards. So let's do a little bit of some demos here, and then we'll get ready to kind of wrap things up. But We've got the ASUS AOC demo that we're going to walk through here. It's going to be some cool stuff, and we got AMP2 that we're going to show off. So for those of you that hopefully had questions on the board, hopefully we quickly ran over that. If not, like I said, we got the full other in-depth live stream where we went over everything there. We've got more stuff that'll be coming on in terms of focused overview guides. Of course, you can also join the PCDIY group, which is linked in the description. But let's get to some performance tuning, and let's do some overclocking. All right, so give me a second to put this board away. I'm going to quickly mute here, guys, so I don't want to hear you guys hear all the rumbling. So give me 1 second. All right, guys, we've gotten put that away there. Nice. I've owned 3 Formula boards. Fantastic, man. Thanks for that great support over the years. That's really, really cool. Somebody else also notes this. Tech Allen, he says, building a vertical. So I'm assuming what he means is actually doing a build, but using actually a vertical mount, so the graphics card would be vertical as opposed to horizontal. It's not the best choice for such a beautifully crafted design. Yeah, I mean, I'm never necessarily actually a fan of vertical. I think if the vertical design's kind of been inherently kind of thought about to be able to be contiguous with the whole design and feel of what you're doing with the system, vertical mounting can be cool. I find a lot of times it eats too much visual space and it takes too much away from the motherboard, so that's the reason why I tend to not like it. Plus, physically, you're limiting access to slots. You have more issues with things like riser cables, so they tend to present more issues. Thermals can sometimes actually be worse also within a vertical mount. But yeah, it would be a shame almost to buy like a Formula and do like a vertical mount. But you know, PCDIY, to each his own. Yeah, everybody can build the way that they want. If they want to be able to go with that look and feel, I'm sure it would still look fantastic. Actually, our friends over at Liquid House recently did a very tight build. They did not have a lot of time. They had very little time, but they did actually a fantastic build for the launch event with Intel. Let me see if I actually have the images right here. Where they actually utilized the Formula, and they did it in a height chassis. And that height chassis, it only allows, of course, for vertical mounting. So build still came out great, but for sure, let me see right here. I think I have it, Intel 14th Gen. Let's see if I have it right here. Do I not have that image? Let me go ahead and see here. Okay, yeah, here we go. Yeah, here you guys go. So this is over from our friends over at Liquid House. And you can see here's a great example of actually this brand new motherboard in a build where you would do a vertical mount. So again, they thought, I think, about a kind of cohesive look and feel. So again, they do a beautiful job at kind of making things look really kind of contiguous. So you can feel kind of just the flow from the silver and the fittings to, of course, the color scheme that they've gone with, translating from that white to then the silver to the blues that's carrying through here, that it does feel kind of a contiguous vibe, but you are definitely limiting that beautiful visibility of that white portion of the board, right? Even this Vantex fan, it's really large. So for me, like I might have maybe gone with maybe no fan, or maybe I would go with actually a slimmer fan, right? Just to be able to have more visibility on the ROG Eye. And that's, again, every builder is going to have a different choice and a different approach, but the build itself, I think, looks stunning. The white still carries through because, of course, instead of this being black, you still have that white prominence that's there. I love the block that they also chose, which has that silver complementary into there. So still a beautiful looking build that carries through, I think, the look and the feel of a premium aesthetic. But definitely you can see that you are limiting part of that visibility. You can see right there, right, where you've got that vertical mount where that whole bottom section, you don't pretty much have visibility to that side, right? But overall, it still does have a great look to it. You know, you could also argue whether or not maybe you would go with like a white Strix card, right? That's like the same thing when like some people would like when they block a white Strix card. Why would you block a white Strix card? Part of the reason why you were buying the white Strix card is to get that really nice heatsink, right? So it just has, you know, different sensibilities, right? I wish you guys had a white themed Maximus. That is a Maximus board. It's the Maximus Formula. So I'm not sure what you mean by white themed Maximus. That is a white Maximus motherboard. All right, guys. So let me go ahead and get my demo up here. I'm going to be using this TUF gaming based motherboard. So we're going to be using a 13700K. We're going to be using the TUF gaming board. And I've got some team group memory right here. So we're going to use this team group Delta memory for the build. Although, actually... well, let me put this in first because I might already have the profile set in for this, and then we might swap because we'll need to swap the memory kit for the AMP demo, but I'll just put that memory in there initially. We don't need to worry about the M.2 SSD. This is actually a Patriot PCIe Gen 4 NVMe M.2 SSD, but for our situations, it doesn't affect the process. But for the AMP memory demo, I'll actually show you the memory kit, and we'll go through a little bit more specifically. But for ASUS AIC, we'll go from there. Now, we could use the iGPU, but I'm not going to use the iGPU. I'm just going to use a basic graphics card. Well, it's not basic for sure. I mean, it's still very performant based card, but we're just going to go with the 4070. This is our dual 4070, nice clean black compact card. So that's what I'm going to use for the demo. Then we've got an 850 watt power supply, and then for the cooler I'm going to be using our TUF Gaming LC2 cooler is what I'm going to use. Let me go ahead and show you guys. This is the cooler in case anybody's wondering about, just like what I'm going to be using here. I'll show you the cooler that I'm going to be using. This cooler will be coming out in a little bit. So it's not even our flagship cooler. This is, but it is going to be a high performing base cooling solution that we do have available. Let me see, do I have it over here? Oh, there we go. Okay. So this is the cooler that we will be using for the build here. So give me 1 second, guys. I'm just going to connect my cables here in a little bit, and we'll get that set up there, okay? Janny's noting, yeah, maybe a Maximus Light Hero. I don't think we would just call it Light Hero. I think it would just be Maximus, and maybe we'd call it like Moonlight White or something like that, like we've done a lot for our other white products, right? Okay. Forgive my red cables with this setup. And it would have been nicer to either keep them black or maybe orange, right? You know, to keep it kind of more in vein with the TUF gaming, but it's fine. Okay. All right, so we've got our setup here. It's all good to go there. And now let me go ahead and see right here. What What PSU is using with the white cables? This one right here, the PSU that I have powering this system, this is our, what do I have in this one? This is our ROG Strix power supply. And for this one right here, this is an ROG Strix Aura power supply. So this is one of our new power supplies right there. Bobby's asking on the old Z790 here, is the memory QVL list for the 13th gen? Yeah, it's interoperable. Don't worry about that. The memory interoperability is essentially the same between the Z790 Hero and the Z790 Dark Hero, and they both support 13th or 14th gen. If you're using the older Hero, though, you do need to make sure to update the UEFI BIOS and the MEI firmware to correctly support 14th gen series CPU support. Okay. Keep in mind though that the Z790 Dark Hero though supports DimFlex, where the prior Z790 Hero does not support DimFlex. Okay. Hey, Warrior 3D. Yeah, feel free to join us in our PCDIY group. I'd love to be able to go ahead and answer whatever questions you might have. Is that an ROG red cable? Yeah, I mean, I guess you could say it's ROG red. It's just a nice, high quality red cable right there. Hey, H2O Computers is going, JJ, I'm curious if you've read about the release date for the ROG Strix white model. Yes, it'll be coming soon. I don't have details for you yet. I know I gave you guys a teaser about it, like a month ago or something like that, but it'll be coming out later, so make sure to keep it tuned. Also, are those new TUF cables like the fully etched modular cables that we have right there? Yes, the ROG Aura Strix Gold cables are quite nice. These are not the cables that come with the ROG Strix Aura Gold. I would swap this out because I was testing an ROG setup and I wanted to do red, so don't worry about those cables. Let's go though to our testing here. So let me go ahead and just get the power connected and we'll get things started here. I don't think I need Wi-Fi, but in case I need to, I'll just connect it because it's so easy to do. Right, got that there. Let me get our monitor connected here so I can actually show you guys what we're going to be outputting. So we can go into the UEFI BIOS. All right, we got our HDMI on there. I've got our keyboard. So we're going to be using our Claymore keyboard there. Sorry, everybody, you might hear that keyboard just a little bit more than normal because I got our RX blue switches here. Okay, all right, we got everything set up. Let's go into our overclocking. All right. All right, got our system powered up here. Let's go ahead and switch. All right, hey guys, you'll see you down here at the bottom of the corner. Hopefully everybody can still see me okay right there. We are just going to be booting up here. So we're just going to be entering into the UEFI first. So I want to be able to show you guys some stuff. Hopefully I'm connected everything. Don't have any variables that are kind of going on there, so we'll see there in a little bit. Yep, there we go. System's posting okay. Namor, yes, we actually will be having a, specifically on this, we're going to be doing a Wi-Fi 7 dedicated stream in the not too distant future where we'll actually do Wi-Fi 7 demo testing speeds. So yes, we will have that coming up in the not too distant future. Okay. All right, guys. So we're here in the UEFI BIOS, right? So if you want to go ahead and go about AIOC, how do you actually do that? And let's actually take a look at some of the cool things you can actually do. So I'm just going to go ahead and load our defaults just first and foremost. So in terms of it, you actually have a really easy option to enable ASUS AIOC. You could go into the easy mode interface and you could literally just click this button and you could go into AIOC optimized mode and you would be good to go. Now, what you do want to keep in mind is that you ideally want to make sure to run essentially some form of gaming session or some type of stress test for a little period of time so that we can actually categorize and index your cooler. That will actually be translated, and once that information is stored, the ASUS AIOC will begin its predictive modeling. Now, I've already been running the system. It knows essentially I have this TUF Gaming LC2 cooler on there and its cooling performance, so I already have my OC results in play. So we're actually going to show you actually how that works in terms of the kind of the before and the after. So if we go ahead and enter in, you will actually see some additional information. So I'm going to go ahead and bump this up here and move myself actually over to this corner. Now, why am I moving over this corner? Part of the information you'll actually see presented here, where you get what's called a cooler score. You get actually some CPU kind of quality information. That's what actually this SP score is. This is an internal, though, algorithm that we define. It's comprised of quite a bit of metrics. And here you have kind of a base target of information that explains to you kind of what we're going to be doing in terms of the overclock, right? Where you can actually see your P cores and then your E cores. So we're actually going to be able to overclock both your P cores and your E cores, and it also accounts for different levels in terms of how they're loaded, whether you're doing lightly loading or heavy loading, whether you're using AVX applications or not using AVX applications. So again, very, very simple. If you didn't know anything, all you need to know is just to enable AIOC, and that's it. But I'm showing you guys some cool other points because I think there's some cool things that you can do with ASUS AIOC. So we're just going to go ahead and load the defaults right now, and then we'll kind of compare and contrast. I'm going to actually go for full Intel defaults, which full Intel defaults will actually be going here, and I'm going to actually enforce all limits. Okay. And then I'm going to go ahead and enable the ability that I can have XTU. So to have XTU, I need to go in here and actually I need to enable undervolt protection. And we're now going to go ahead and reboot, and we're going to go back into the operating system. So once we get back into the OS, we'll go ahead and show you kind of your before and your after and your kind of comparative results and kind of what you would be able to see when you take a look at kind of overclocking and kind of what your performance benefits can be. Because I know some people talk about like, well, isn't the CPU really hot, and like why would you attempt to overclock because that's even going to produce more heat? And what we really kind of want to show here is, if you account for realistic usage, so you talk about kind of normal desktop usage, you talk about gaming usage, your thermals are very easily actually be able to be managed actually on even something like a tower heatsink. I can use this Noctua U12S, and this will cool that 13700K, and I could even still enable ASUS AIOC with this cooler and still be having manageable temperatures for my desktop and gaming work usage. The only time that you would really have to account for having significantly higher thermal dissipation performance is if you're somebody that's going to maybe be consistently doing a lot of multi-threaded workloads. So you're doing applications that are using all cores all the time, and that of course will produce much higher heat loads. But for most users, that's usually not the case. That's not a factor, right? So we should be getting ready to boot up in here into the OS in a little bit. There we go. So we're actually in the OS environment. Hi guys, you guys can see me here. Let me go ahead and move myself back over right there. Okay, so we are in our OS environment. So I think right here I should probably have my kind of my before and after. So let's go ahead and look at this. So yeah, I can go ahead and actually open up XTU, but the value should pretty much be the same here. But we're going to go ahead and open it up. All right, and so right here, if you actually open it up, you can see right here, that's actually our corresponding values. And let me know, guys, if you're able to see that okay. I think I reduced the resolution, so hopefully everybody should be able to see that okay. But you can see here we have essentially a 1-core maximum, which would mean up to 5.4 gigahertz, right? And then all the way down to 53, which would essentially be all cores, right? So you can see these are all of our P cores. So essentially 53 all the way up to that 54, okay? And then we can see our E cores, right, which are all pretty much locked in at 42. Okay, and you have that similar kind of information broken to you down over here, right, where it's showing you the 53, right, and then your favorite cores, right, there's a 54, so that maximum turbo boost frequency under select scenarios, and then here you can see 42. Okay, so that's as we confirmed right now, we just loaded our full enforced defaults. There we go, right? So if we compare that here, that's going to be the same information that I have pretty much right here. So we're going to open up this. And then if we engage ASUS AIOC, what would we essentially be getting? So we can go over here and we can compare our results. So this is our ASUS AIOC result right here. And this is our essentially stock results right here, right? So let's go ahead and take a look at what you would be able to get. So here we can see the comparison of what you would actually be able to achieve. So again, 53 up to 54, this is our stock. And then you can see here what ASUS AOC was able to overclock for you that was specific to our CPU and specific to our cooler is 57 all the way up to 60. So actually, so 5.7 gigahertz all the way up to 6 gigahertz. And you can see that we have a really nice intelligent per core loading model, right? So 57 would be all core workloads, and that's all going to be all the way up to FL4 cores, right? And then we can see as we get over into 3, 2, and 1, we're at 59, and then at that 1 core peak, we're at 60. We're also leveraging the intelligence of what's called TVB, which is thermal velocity boost, which means that that boosting behavior comes into play based on the CPU target temperature. So it's not just being ramped up artificially, it's contingent to be in alignment with the actual CPU temperature. As the temperature's in play, it will boost up accordingly. Now, you could make adjustments to that if you wanted to, but overall, you can see that this is a really healthy overclock. We can see we were already at the maximum of 5.4 here, so that's actually up to 600 megahertz. Right? They were actually increasing the frequency, right? So that's a sizable overclock. And then the all-core overclock is a 400 megahertz lift. So 400 megahertz on the all-core. And then we can see at the top end, it's going to be, 600 megahertz, right? That you're going to have, right? Then when we take a look here at the E-cores, you can actually also see the E-cores have also gone ahead and been bumped where we went from 42 where we actually went to 44. Now, the next thing that we actually want to take a look at is going to be, well, how does that actually translate into thermals and temperatures, right? So let's go ahead and now actually take a closer look at that information. And then we're also going to look at some other cool stuff in AIOC in terms of if you wanted to kind of customize it further, right? Let me go ahead and open up right here. This should be our all limits. So here we've gone ahead and loaded in a game. So this is the Final Fantasy benchmark. It's actually a pretty well-balanced game engine in terms of actually using quite a bit of some additional cores, but also definitely being lightly threaded, so it gets a benefit. And so it's going to be hitting the cores at a pretty good kind of peg to be able to kind of target, essentially showing off what the realistic world temperature performance is going to be from the kind of the stock overclock scenario, stock non-overclocked to our overclock configuration and what we would be seeing for temperatures. So if we take a look at the first temperature value, this is logged across 30 minutes, okay? So kind of a good little gaming session that we have right here. Let's go ahead and take a look at it right here. Oh, actually, sorry, let me make sure that we're opening. So this is going to be our stock value. So let's look here what we got for our stock value. Stock value, you can see right here that your overall recent maximum was 58, right? And the overall recent average was 40, right? So overall, you can see that the temperatures are already just great in terms of gaming, right? You don't have to be worrying in the first place, right? It's overall really not an issue at all. You weren't even getting to 60 degrees, right? But now we can go ahead and see, well, what happens if we overclocked it? Now, keep in mind this overclock, it's also with a 7000 MT memory overclock on there, which also adds a little bit of additional heat because the IMC memory voltage is also increased. So we're increasing both CPU voltages and the IMC voltage because we have a DRAM overclock. Okay, so here we can actually take a look and let's look. The recent overall minimum, they're pretty similar. So 33, 36, just a little bit more. The recent maximum was 69C, and then here the recent maximum was 58. So overall we see an 11 degree bump, right? But overall it's under 70 degrees, right? That's 6 gigahertz overclock. It's like, why wouldn't you actually be overclocking? Because you would be leaving frequency on the floor, right? You're not thermally constrained. So a lot of times this messaging of saying they run really hot, well, it depends on your workload. Now, yes, if we ran Cinebench for an hour, yes, you're going to have much, much higher temperatures. But if you talk about what you're really doing, unless you're a professional creator, where probably professional creators probably wouldn't be overclocking their system. And it even depends, because if they were doing photography, they could still benefit from the overclocking, because Lightroom, take for instance, is only lightly threaded. It's not a multi-threaded application like Premiere or After Effects or some other applications are. But you can see the delta here, 58 to 69. So still very reasonable temperatures. And overall, look at the recent average. So the overall recent average as opposed to just the max, because keep in mind a max might have just happened for just a small little burst duration for a little bit, but the recent average was only 46C. So 40 to 46C. So there we have an 11C delta, and here we only have a 6C delta. So yeah, so Thomas is noting right there, nice. I would agree. That's a really nice bump up in terms of the overall performance that you're getting. And again, this only takes one click, literally one click, and the system will automatically do this for you. But that's not where it stops. There's some other really cool stuff that we want to compare here. So now we're going to take a look at some other things. Let's look at the max P core frequency. So this is going to be the max frequency that's detected in terms of the actual P cores. So here we can see, again, this is at full stock. So full stock, we can see that the maximum that was able to be target was actually only 5.3 gigahertz. So it didn't even get to the opportunistic value of that potential 5.4. So the maximum that it had under that real world gaming scenario was only that 5.3. Okay. And then if we go ahead and compare that here to the ASUS AOC demo, we can actually see we got a really nice healthy uplift, right? So our recent maximum average right there was 5.84 gigahertz, right? So that's over a 500 megahertz uplift in terms of the frequency that we're seeing in terms of the recent maximum for the gaming average, right? And again, you can see your recent average is higher, your recent maximum is higher, and then also critically, ASUS AIC does something that is called an adaptive voltage with the full voltage frequency curve. That means that the CPU frequency still comes up and down based on load, and the voltage comes up and down based on load. So that's advantageous because it still means that we get the really, really good low idle temperatures, really, really good minimal kind of frequency without kind of, you know, having your CPU run aggressively when it doesn't need to be running aggressively, or running higher voltage when it doesn't need to be running higher voltage. So again, you can see higher frequencies are achieved here in a real world gaming scenario. So we're able to consistently see up to that 5.84 versus that 5.3. Okay. And, if we also take a look again here at that P0, which is going to be a key one for like lightly threaded applications, right? That kind of mirrors with that same feedback that we saw from the max P core, right? So we could see right there, 5.3 gigahertz versus 5.83 gigahertz. So we can see that it was effectively able to go ahead and give us that bump up in terms of the overall performance, right? And, you know, from a stability standpoint, again, here is just because, of course, we don't have an hour to run, but I'm showing you right here. Here's the actual ASUS AOC results. So you can see actually all of the AOC loaded values. And we went ahead and we ran the OCCT full stress test under extreme for 1 hour. You can see there that it passed with full stability without any issues. So that's pretty cool in terms of, again, giving you a very, very good level of confidence in knowing the system's working, right? So now I want to go ahead and show you actually some cool stuff in terms of like how you could further customize ASUS AIOC. And from a performance perspective, you know, how you could kind of tailor it and you could kind of do some cool things with it. So let's quickly just look at some temperature stuff and how you can kind of work with ASUS AIOC if you wanted to kind of tweak or tailor it. So let me go back out here. Oh, sorry, I probably need to make sure that I'm watching my display right there. All right. So what we're going to do right now is we're actually going to load the system at defaults. And we're going to include actually just the full UEFI BIOS defaults. And we're going to then run a quick stress test so that we actually see what kind of maximum thermals are. But one of the cool things you can actually do with ASUS AIC is that you can customize its aggressiveness, but you can also further even customize elements like its actual overclock based on temperature. So let's say you don't really understand things like voltages and frequencies. You just know, hey, I have a preference that I'd like to try to make sure that it stays underneath a certain target value. That's something we already do by managing what's called a thermal velocity boost and using certain predictive values. But you can even kind of fine tune this yourself. So just for reference, again, I'm going to go in and I'm going to load full default. So this is just full F5, nothing else. I will still go in and enable XTU just so that we have XTU information. So I need to go in and again enable the undervolt protection because that's a requirement for XTU. And we'll go back into the UEFI BIOS. All right. Excuse me, not back into the UEFI, but we're going to go back into the operating system. So let us go back into the OS. And for those of you guys in the chat, are you guys running right now overclocked? So why don't you guys let me know in the chat. Are you running overclock or are you running stock, right? So which one are you running? Are you running stock and you're running overclock? Now, this is for your CPU because probably if any of you are running XMP, even though you might not consider it an overclock, that is an overclock because the memory is, of course, operating outside of the defined operating specification. So you could be running CPU stock, but you could be running your memory overclocked, right? Okay, so we are back now in the operating system environment. So now that we're back in the OS, we're going to give it just a little bit of time to load right here. Once it's gone ahead and loaded, we are then going to essentially engage a stress test, and we're going to check kind of temperatures. Now, this is a stress test. It's not indicative of a game. Of course, with the game like we talked about and what we just showed, the temperatures would be much lower, so you wouldn't have to kind of worry about this. But I just want to show you kind of like in a scenario that even if you wanted to use a stress test as a benchmark, how you can adjust that. So let's go ahead and look at this. So we're going to go ahead and open up OCCT. Now I'm using OCCT Pro. I do recommend if you guys want to check it out. One of the cool things is Maximus series motherboards come with a full licensed version of 8064, which also offers a stress test, which is quite nice. Okay, but let's go here. I guess you could go to the CPU test or you could go to memory tests. It doesn't matter. Different loads though are going to have different effects in terms of the actual temperature. Okay, so let's go here to CPU, and we'll give it a little bit, but it's going to ramp up pretty quickly in terms of our core temperatures. Okay. So we'll give it a little bit to kind of load up right there, and we'll just give it a little time here to kind of ramp up. So looks like Namor notes XMP only. Then Thomas is noting a memory overclock, and then Tech is noting overclocked memory. So it sounds like you guys are just running just XMP, but you're not overclocking the CPU. Okay, so we can already start to see that our nominal values right here, they're floating between here. We got 74, we've got 81, we've got 83. Now it's being handled pretty well already by our TUF Gaming LC2 cooler, right? So these temperatures are already pretty reasonable. I have it on a turbo fan curve. It's not even on a full fan speed fan curve, but it's on turbo. But we can see our peaks have already started to go up a little bit higher. So we have 87, 87, 84. Now those are just your peaks, of course. Here, this is your realistic value, which of course will kind of vary up and down, and it will change a little bit over time. But you can start to see you're starting to have a higher saturation point as far as those thermals getting up to, let's say, like whatever 100 C might be. Of course, we could even go higher than this, where we could stress it even more. We just saw now 87, 87, 84, 77. If I go back out here and use the PSU test as well, PSU test is a pretty heavy test, and it's actually going to power everything. And I'm going to reset our minimums. You can actually see how in the PSU test I can even hit the temperatures even hotter, right? Like I can go here 87, 100, 100, 98. So you can see we pretty much maxed out, but the PSU test is designed to exert kind of that highest heat load, right? Again, games, normal applications won't do this, right? But the point that I want to show you here is how we can actually account for this if you even wanted to still have like an overclocking in play and still use, let's say, a stress test. So you can see right here we got up to that 88, 100, 100, right? And there's 100 for the package, right? So now let's go ahead and just quit on that, and we're going to go ahead and enable ASUS AIOC. So you can enable ASUS AIOC really easily either from within the BIOS, or you can also do it within the Armory Crate software. So it's up to you as far as figuring out which one you want to use to enable it. It doesn't matter. So right here, I'm just going to go ahead and toggle this on, click OK, and that would be it. That's all you need to do to enable ASUS AIOC. It's very, very simple. So now it's going to go ahead and reboot into the UEFI. And I'm going to show you guys some of the cool stuff that you have available to you in terms if you kind of wanted to customize. Now, we already saw in the prior example how ASUS AIOC can easily give you higher levels of performance, right? Where we went up, 600 megahertz, right? In terms of our overclocking range, right? Where we went from like 5.3 to, of course, 6, which actually that's 700 megahertz, right? But it depends on which multiplier we're comparing, right? And which number of cores. But you do have granularity and control to kind of tweak this. So even if you're somebody that's not familiar with all the technical kind of parameters, the really cool thing with ASUS AIOC is you can go in here and you can go over into the ASUS AIOC section, which is going to be right under here under AI features. And you have some really, really cool options. So one of them you're going to see right here is an optimism scale. So the optimism scale will actually let you either make the overclock more aggressive or more conservative. So let's say you actually really enjoy this, you've been having it run great, and you go like, can I even get a little bit more performance? Well, you could go up. You could do maybe 105, and that would actually bump up the algorithm and say, hey, let's go ahead and try for a little bit more. Now, we divide the 100% optimism scale after we've actually tested hundreds of CPU samples to kind of know generally the success rate of what we're going to target in specific to your CPU quality when we measure it, and then specific to the cooling performance that we also measure, right? Inversely, if you wanted to actually be more conservative, you could actually go down, and instead of picking 100, you could pick 90. So you actually have a way that you could make the algorithm essentially more conservative, or you can make it more aggressive. So that's the first level of customization that you actually have available to you. Another one is you see right here with the cooler reevaluation algorithm and this cooler efficiency customization, where it says keep training and how often you actually want it to be updating. So we're consistently always monitoring the CPU temperature. And the reason why we do that is because if your CPU's temperature performance went down, so your cooling performance, if this actually went down, we would actually bring down your overclock. This is even better than if you manually overclocked, because if you manually overclocked it and you just left it overclocked, but let's say your pump went bad, or maybe the fan started to fail, or maybe your ambient temperature started going up a lot from, let's say, like the winter to like the summer, right? Your overclock might actually be worse performing, right? Because your temperatures are, of course, becoming worse. But now, because we're consistently monitoring the temperature, we will actually bring down the frequency. And this also works the opposite way. If you had lower temperatures, let's say going from the summer going into the winter, or maybe you upgraded your cooler from like a 240 millimeter AO to like a 360 millimeter AO, we'd actually would keep categorizing your cooling performance and go like, hey, you're running a better cooling solution. We might actually be able to overclock more than you used to have. So that's pretty cool. Now, another really cool feature that you're going to see right here is going to be this option right here, where you see it says this packet temperature threshold, and then regulate frequency by the above threshold. So if I go ahead and go to enabled, and let's say I pick ADC, okay, you can actually designate that as being the relative kind of target for your temperature that you want the system to overclock towards. So in some ways, you're actually overclocking specifically by a temperature. Now, this is actually pretty similar to what kind of the boosting behavior already does by itself, because right now the boosting behavior that Intel defines is based off of temperature, right? So if it kind of gets to certain levels, whether it's below that level or above that level, will define the frequency that it gets to. But here, the cool part is that you can kind of define that for yourself relative to our overclocking pursuit. So if you really, really want to be underneath a certain kind of target temperature, you can do that. So we are back into the OS. We'll go ahead and let it load up, and we'll show you actually how that would work. And you can see right there that we essentially just booted up back in with the ASUS AOC, and you're good to go. Again, you didn't have to do anything in the operating system. If you wanted to engage it from the UEFI, you could have done that all within the UEFI. If you wanted to enable it from the operating system, you can enable it within the operating system. So we're going to go ahead and we'll open up our OCCT. I think everything is loaded up there in the dash tray. I have IQ and some other utilities installed on here, so it could take a little bit longer, but overall, for the most part, it should be pretty close to it. So if we go back to our same original CPU test, right, and we start this, let's go ahead and start this off. Now, you're going to see right here, we hit it really quickly, and it did peak up a little bit higher. But we're going to reset the average, and the reason why is because we have to give it a little bit of time to just be able to catch up and make an adjustment. So now you can see right here, where when we reset that average, you can actually see now that the max temperature that it's recording, yeah, we got to 81 or 82 because it's not 100% perfect, right? But it's about as tight as we can make it to be, where you can see your nominal averages are pretty much now running into that wall at about that 80 degrees. So that means we've now effectively hit essentially like that 80 temperature target. So it won't allow it to essentially keep going up any higher. Essentially, we've dialed in that essentially that overclock to that 80 degree target. So it's a very cool way to essentially be able to kind of lock in kind of an overclock range, but associated with a specific temperature target if that's what you want to be able to do. So it's a really cool level of flexibility they have. And again, you can go in and you can customize that. You could have it be 80 degrees, you could have it be 85 degrees, you could have it be 90 degrees, or you don't have to do anything. You could just enable it and just leave it with what we program it, and we try to find that best balance right for you. And it's, again, very efficient, very effective at being able to do that. Okay. So We're now also going to show you, I think, AMP, but I lastly want to show you one other cool thing that exists within ASUS AIOC, which is going to be, because we actually have a little chip that's on the motherboard, it's a microcontroller. This microcontroller is sensing a lot of different stuff. It's a lot of different information that it's tracking. And one of the cool things that we actually have access to is going to be the ability to see kind of information over time in relation to your CPU. So I want to show you how this guy's works. So overall, now that I've kind of showed you some of those things, guys, what do you think? What are you thinking? Do you think it's pretty easy? I think it's pretty easy. And again, this is something that we've refined from generation to generation to generation. And it's a really robust and mature way to, like I said, if you've got a K-series CPU, you've got a cooler, all you need to do is just turn it on and be able to get more performance from your system, right? So one of the other cool things is if we head over here and we go into the AI features, you can actually go to this little tab right here that says processor utilization. And under processor utilization, you can see right here, you've actually got some cool information points. So you can actually see how long your CPU has been running, 35 hours, 32 minutes, and 38 seconds. You can actually see the accumulated voltage, the accumulated current, you can accumulated temperature, your power, and even this is really cool right here. What's your average CPU temperature over time? What's the average current for your CPU and the average voltage? So you can see, even though I've been running ASUS AFC, I've been doing all these stress testing with it, look what my overall relative average of voltage is. Because sometimes people go like, hey, that voltage seems like it's high when it's peaking, but keep in mind, ASUS AFC is doing what's called a voltage frequency curve, right? You can see that right here with all these cores, right? There's an intelligence to essentially what you're applying. It's not like what's called a static voltage, where a static voltage is giving you essentially a fixed voltage regardless of what you're doing. You can actually see that the voltage will go up and down. So you see, like when it goes all the way down to 800 megahertz, look what the voltage goes all the way down to is 0.734. And then as it goes all the way up, the voltage increases, right? And it could only just be for, for a second, right? That it's increasing to that and then it comes down, because this is what is called an adaptive voltage policy. So it's very, very intelligent. But the cool thing is you can actually see that information here under the processor utilization, where you can see the actual average voltage over time. Right, so really cool. Mike goes, as I use Intel XTU right in Windows. Yeah, so XTU is going to provide you a much lower level of overclocking, and it's not CPU specific and cooler specific. So it definitely can provide you a little bit better performance. It's not a bad kind of stepping stone, but compared to ASUS AFC, it's significantly more basic in terms of the performance that it can give you. And I think the big thing is with ASUS AFC is it's going to be specific to your motherboard, your CPU, your cooler solution. So that's really the big advantage, right? And we've also modeled it over, like I said, hundreds of CPU samples. It's actually something that Intel attempts to be trying to do now with their latest form of kind of like an AI-assisted overclocking feature specific to 14th Gen series CPUs that they're launching right now just with the 14900K, and that they're saying they're going to maybe offer for other CPUs over time. But overall, really, really cool. So the last part here that I'm going to show you guys is going to show you AMP. So let me show you the way that AMP works. So we're going to go back over here. And for AMP, I'm going to show you guys this here. So I'm going to go over here to my second cam. So this is a pretty basic stick of memory right here. Generally, you guys want to minimize touching any, of course, the primary contacts on there. But these are essentially non-XMP kits. So this is an XMP kit of memory. So this is, I think this one's a 7000 kit, 7000 MT, right? So you have higher performance kits that have an XMP profile, right? Then here, this kit is only a native 5600 kit. The cool thing is that we have essentially a technology that allows us to analyze the ICs on here and then tune these to a higher level of overclocking, similar to kind of like ASUS AFC, but for memory. The cool part about it is going to be that I think for those of you that are kind of on a more limited budget, that maybe you don't want to jump up to buying more expensive memory, and maybe you're just looking to run Intel basic stock specifications, but maybe see if you can also get maybe more performance, this could be a really good option, especially if we pair this with something like the TUF gaming motherboard. Namer goes, is this Crucial memory? That's actually not Crucial memory. This is actually Kingston memory. There's different vendors that make that type of memory. Crucial does offer memory like this. Patriot offers memory like this. Like this is another kit of memory. It's different than the one I just showed you. The one I just showed you is from Kingston. So this is from Patriot. So this one's a 4800 MT kit, right? And I can show you actually A&P results for that kit too. But essentially these are just basic these will also be generally the cheapest memory kits that are on the market, okay? Than of course buying a higher XMP memory kit. So let's see how this works. Now I'm back in my desktop. I'm gonna shut down my system because of course we need to physically change the memory. Yes, these are SK Hynix ICs, of course, but they would be SK Hynix, right? Because when you talk about all memory right now, you're either going to have Samsung, you're going to have Micron, or you're going to have SK Hynix, right? It doesn't matter. It could be Micron, it could be SK Hynix, or it could be Samsung. The A&P will work for any one of the IC vendors, right? So we will still be able to do this overclocking. Of course, the margin will vary between them, right? Generally, SK Hynix right now will offer the highest scaling, right? And most of the 5600 native kits on the market that are going to be like this, that are going to be native, are probably SK Hynix. Although there is now Micron kits that are also native 5600 as well. So they're not exclusive. But generally, if you talk about the margin of what A&P will offer, the highest value would generally be for SK Hynix, then followed up by Samsung, although the latest generation Micron's pretty close to the Samsung, and it can actually get some noticeable performance improvement as well. But the whole point here is that you don't have to know anything about this. If you just wanted to essentially buy just a nice, stable, reliable system, I just bought this 5600 kit because that's what 13th and 14th gen officially support as their maximum speed. So maybe I just want to run pure stock. But then I realized, hey, I just bought this memory. It was pure stock, stable, reliable, good memory, but maybe I can get better performance. This is what you can do. So let me go ahead and show you how this works. So I'm going to go ahead and remove my team group memory. This is of course much faster. These are 8,000. That's 8,000 MT kits there. Sorry. Okay. All right, got my memory installed. Start our system. And we'll go there. So let me see right here. Hynix will give you better SC margin. Yes, that's what I just noted. I really hope that Micron and Samsung can offer. Yeah. So I think you always see that as progress over time, that different the IC vendors are continually kind of revising and making improvements, right? As far as that goes. Namer goes, I wonder why they even came up with XMP instead of native high MT. They're two different things, because the native high MT memory, right, that is designed to be in alignment with the port table, so the memory specification from Intel and from AMD. XMP is kind of realizing that both AMD and Intel offer you the ability to overclock, right, the DRAM divider, and that's essentially always going to be a theoretical. Even if you can have it to a pretty high confidence, it's not a guarantee. And so that's why there's a fundamental difference, because you essentially can do this, what we're doing on this, but prior to XMP, right, the user would have to know how to set the memory divider. They would have to know the memory controller voltage to adjust. They would have to adjust other maybe voltages on the board, then the tuning parameters, all those things. So they essentially just made it easier by creating a profile to allow you to essentially overclock with the profile in place, right? That. So we're now back in the UEFI. So we can go right here and we will go over. Now, all of our motherboards have a really cool feature that they have built in here that we call actually the SPD tool. So you can actually go in and you can find information about your memory. So you can see right here, it tells us this memory module is manufactured by Kingston. It does actually use SK Hynix memory. And then it actually tells us right here, you notice there's no XMP because this is 100% not an XMP module. And its native timings, it follows the default Intel memory spec, right, for the port table. So 5600 MT, and then you can see your primary timing. So 46, 45, 45, 90, 135, and then the default voltage value of 1.1. So you can see all that information. You could even save a screenshot if you wanted to of that. You can just put in a flash drive, you can hit F12, and you can save that information if you wanted to have it. But what do you need to do? You just head over here and you go to auto, and you'll now see instead of XMP, you see an option that says AEMP, right? So you just now hit that, and it will tell you, hey, tuning progress starts now, and it may take a few minutes. It actually usually takes less than about 30 seconds, and it will turn back to your result. The result could even potentially change after 1 reboot or 2 reboots, but generally it will be pretty consistent. And you can already see right here, what did it do? It already now has changed our DRAM timing values and information, and you can see right here that it has gone ahead and set 6800 MT memory. For this kit, depending on the CPU and the board, I have another one where it actually was able to run 7000 MT, so I was able to take that and run that. But you can see that's literally all you needed to do. So you could have bought this 5600 kit, and now you're able to get this 6800 MT. And again, if we go back to our base timings, that was also C46. Now we see right here that the motherboard is running at 5600 because that's what it posted at. And if we go back to the easy mode environment, we can also see right there, it's 56, right? So we're gonna go ahead and need that and go okay. You don't need much more than 6,000 for games. 6,000 is good, but it's so easy for Intel. It's also the cost parity. It's like it makes more sense. Why not just get more performance? It also depends on your target. The reality is that, you know, with faster refresh rate monitors, so 240 hertz, 360 hertz, upcoming even faster 380 or 540 hertz monitors, faster GPUs, having actually more bandwidth that you can provide to a multi-threaded processor can give you more performance, and it can be advantageous to just giving you essentially those extra frames to be able to hit higher refresh rates. Again, 6,000 I think is a very nominal target. That's only 400 megahertz, 400 MT, right above the 5600 MT spec standard, and it's definitely a solid value, but we can easily get more than that, right? Yes, that's a great point. Savvy's noting there that more games are becoming, and that's also because more games are also getting more threaded. Keep in mind, one of the key value points of DDR5 memory is DDR5 provides more bandwidth per core. So you actually get better multi-threaded performance as you also have more bandwidth. So ultimately, again, if you can provide more bandwidth, you just get overall better application performance, you get better gaming performance, right? So it's performance that's there on the table, so why not necessarily kind of take advantage of it? So we're going to go ahead and let our board go through the training process here, let it train here. I'm going to go back over here quickly, and if I go back over to my desktop, I can also show you also a validation process right here. So this is actually from a similar setup for the 5600 MT with the AMP. So you guys can see right here. So here you can see there's that 5600 MT kit, and you can see right there that we were able to go ahead and run it at that 7000 MT through AMP2 on the TUF Gaming motherboard. So again, not even on the higher end motherboards. This was actually with our even prior launch firmware for the board, and you can see passes the full memory validation in OCCTT. So really, really nice in terms of giving us a higher level of performance by just literally accessing that one function within the UEFI. So pretty sweet, right? So let's go ahead and go back over here. So we're going to go ahead and drop our validated results right there. Now back in Windows, we can see that it's posted. And we'll go over to our Task Manager. Task Manager is actually the fastest way that you can check your memory speed if you didn't know. You can just go open up Task Manager and you actually see, what did I say? It actually made that adjustment through the memory training, and it ended up giving us the 7000 MT. So you can see right there, we were able to go from 5600 MT to 7000 MT. And now if we go ahead and we check our timings, let's go ahead and open that up. So we can see right here, we open up CPU-Z, and we can check, yes, this is on the TUF Gaming motherboard. We can see our memory, and you can also see, yes, so 7000 with our timings there of 38, right? So quite a bit nicer. So again, if we go ahead and we compare that, we can compare our values. So we went all the way up to 7000 MT. And then here we can see our base memory, right? So in our base memory, you can see, right, you had that that 46. So we went over to 38. So we had a reduction. So we're not only getting faster, right, more bandwidth, but we're also getting more efficiency. We're getting better timings for overall performance as well, right? So you can see right there that your timings were also reduced, and then your primary frequency was reduced, right? So overall, it's a really, again, easy way to just be able to take an entry-level kit of memory and to be able to get more performance. Now, for you guys that are, of course, going to be doing general overclocking, right, especially on a higher end board, you're probably going to be buying, like I said, these memory kits, like, you know, this one right here, the Kingston that I have right here, Patriot, Mushkin, Corsair, right? You know, this is from Corsair, right? This is from Team Group, right? Where you might have XMP profiles. So this won't apply to you. But for those that I think, like I said, the reason why I wanted to show it specifically on a TUF Gaming motherboard, that's a more entry-level motherboard. It's a lower cost option. And that might be more likely for maybe somebody to just want to buy maybe like that 5600 MT or maybe these even cheaper 4800 MT kits and then still be able to do an overclock like, you know, 6400 or something like that, right? And just do it easily where, hey, I can just put that in and be able to get some additional performance. So it's a pretty cool function and feature that, again, we have. All of the Z790 motherboards have that AMP2 feature. So that wraps up our kind of quick performance demo that we wanted to do, showing you guys some of the cool stuff with ASUS AIOC, and then also showing you the AMP2 feature. In our future live stream, where we're going to actually do some overclocking with the 14th gen with ASUS AIOC, we're also going to take a closer look at the DIMFlex technology and show you guys that, because that's going to be pretty cool. And we'll talk a little bit more about some of the kind of overclocking expectations you can see for kind of the platform, although they're pretty close to 13th gen, so they're going to be pretty comparable in that regard. So overall, guys, that wraps up this week's PCDIY weekly live stream. I'm going to quickly check to see here if we got any quick questions that might have came up from, I guess, the demo in terms of kind of jumping into ASUS AIOC and AMP2 overclocking. See if anybody has any questions on that. If not, as always, if you guys have more questions, comments, feedback, anything like that, you can feel free to check us out on our ASUS PCDIY group. It's linked in the description. It's a great community that we have where you can find myself as well as our community moderators and admins to be able to hopefully give you some insight, as well as over 45,000 other people that we have there that might be able to answer your guys' question, especially for if you're looking for insights into ASUS. So let me go ahead and see here if we had any feedback or any thoughts. Yeah, Sabby goes, some people were showing, it depends when you talk about like sometimes using those independent DIMMs, right, where they might have been getting what's called screened kits. So it might just not have the heatsink and everything, but they can have screens kits. Because of course, yes, I also myself have some early screen kits that that they weren't XMP, kits with like a whole heatsink and everything like that. And, and I was able to do over 8,000 MT on some of those memory kits. But there's a lot of other factors you have to account for. Like I said, thermals are another big factor for the extreme overclocking community. That's the reason why the Apex board comes with that 60mm fan, is it critically, like I said, especially as you start to get higher and higher temperatures, you really want to try to have your DIMMs be operating underneath about 55C, to about 60C is really the sweet spot. Once you start to get 65 to definitely, 75 and even 80C, you can start to actually notice depreciable bandwidth reductions, and you can also, like I said, have instability. But we'll talk more about that, I think, in our DIMFlex overclocking segment, which we'll have in the next live stream. All right, guys? But overall, hopefully you guys found this interesting and useful. As always, we're here to give you guys insight when it comes to ASUS's latest and greatest in their hardware, hopefully help you take advantage of your ASUS hardware in the best way possible. So with that, guys, let's wrap up the stream. Take care, take it easy, enjoy the rest of your day, have a fantastic Friday night, have a safe weekend, and best of luck with your builds. All right, guys, take care.